Back to the study days, let's go. Actually, not too excited about that, but hopefully I can just get this out of the way quickly. A couple more I want to do. This not being able to get an SSD is really causing a problem because I can't do any of the projects. I mean, I don't know, I'm going to try to find a way to do that because I just can't get my hands on an SSD. They're so expensive. And it would be a absolute shame to have my computer all set up, spare computer, and all it needs is an SSD. But at any rate, this is going to be useful. So the Splunk Certified Core searches, fields and lookups, alerts, basic reports, dashboards. So this is going to be pretty good to have on there. Get certified in that. So what am I going to do here? I think I'll just add. Yeah. Okay, I can do it here. What is this? Splunk Core Certified User, yeah. Okay. I can do that. Also, how do I go back? And I'll add it also here. And technically this would be a course outline type of deal here. I think the training for this is free. So I'll start off with just the setup here. It's 60 minutes and 60 questions. So hopefully it's not too much of a study. Exam requirements, test your knowledge, sample questions. Okay, should I take this? I should add this maybe. Maybe, actually, if I go back here, this is probably the objective. Oops, my bad. I literally could not mute in time. Okay. I'm gonna put like details here like that. I think that's all I need here. $60 minutes, 60 questions, $130. Pearson view. Okay. Let's see. Resources, probably at the bottom here. Let's see. Exam requirements and recommendations. Let's see what this is all about. You can open. Okay, I guess not. Time to study. The following courses may cover content included. Learning path here. Okay, I'll do that here. I'll add that here. So this is the learning path for it. So it's going to be Intro to Splunk. Using fields, and I'm going to add this for my own notes. Scheduling and scheduling and alerts in Splunk. What else? Visualizations in Splunk. Working with time in Splunk. Dude, let me add this to the dictionary. Come on now. What else? Dang, there's actually a decent amount of courses in here. Okay. Load more. Okay, I wonder how much these are. Statistical processing in Splunk. 4 hour, 3 hour. Oh, these are kind of long actually. I'm not going to be typing my notes with this keyboard actually. I think I'm going to switch to my old setup just so I can use my keyboard that I'm better at typing with, I think. Leveraging lookups and sub searches. Splunk. Intro to knowledge objects in Splunk. I'm just adding in Splunk to everything. Splunk. Oh, and then maybe search optimization in Splunk. Or should I just say Splunk search optimization? What's better? Splunk search optimization, Splunk intro to Splunk. Maybe just some of them. Like this one can just be Splunk visualizations. And then the actual Splunk Core User certification. Resources. I guess I'll take this as the, oh, maybe not. I'll take this as the course catalog. What else? Study guide. Here we go. Splunk study guide. What else? Let me see, let's look at this. Is this a study guide or just what's on the exam? 57-minute, 60, which evaluates create basics of Discord reports. Sample questions. Oh yeah, okay. Certified power user. Okay, but then the rest is everything else. So what would a sample question look like? Which command is used only to create a time series visualization? Time chart or time series? Interesting. Field aliases. What type is used in creating a post workflow action? Time chart. Oh, select all that apply. Okay, interesting. I don't know how much of a study guide this is. What else? Test blueprint, what is that? It's been a while since I used my other keyboard, so let's see if I'll be able to even smoothly transition back to that. What else? Registration tutorial. I feel like that's straightforward, but I'll take it anyway. Okay, that's looking good. Now, I wonder why, what was that other thing that I was at? Because the other one did not look... Splunk Fundamentals Legacy. Was it the Legacy that I was on last time? I was on some other page. My training? This is where I was last time. Step. I don't know what the difference is between this and this. If I register... Oh, it's gonna take me in here anyway. What is the fast start? Certification study path. Okay, I have a study path. What is the difference? Intro to Splunk. Let's see if it's the same stuff. Intro to Splunk, using fields, scheduling. It looks like so far. Visualizations, working with time, leveraging lookups, knowledge object search optimization. Yeah, this is the whole thing. Okay. Let me switch to... Oh, man, how am I gonna... Oof, I might have to unplug this. How am I gonna do this? Okay, I gotta move my laptop. Back to study mode. Let's see, is this gonna work? Is this gonna work? Okay, almost. Uh-oh, what happened? Nothing? Okay, maybe nothing. What is the difference? Using fields, e-learning, using fields. E-learning with labs. I don't know what that is. Could I just do this? Weird system they have here. I don't know what's going on with this.
Hello, welcome to Introduction to Splunk. I'm Alex with Splunk Education. We're so glad you're here with us, beginning your journey of learning about Splunk. Whether your goal is to become a Splunk Enterprise admin, run searches, and build dashboards in the Splunk Cloud environment, or dive deeper into your data using one of our premium solutions like Enterprise Security or Splunk SOAR. In this course, we'll cover what Splunk is and get hands-on with the interface, running searches and using commands to create reports and dashboards. We'll learn about how knowledge objects can help enrich your data and how to integrate them into your overall workflow. The scenarios in this course will focus on data ingested by Buttercup Games, a fictional gaming company with offices in San Francisco, Boston, and London. Their games are sold by vendors across the globe, as well as in their online store. They ingest data from their online and retail sales, as well as game logs, firewall and web security appliance data, and internal security data related to badge reader access and Active Directory credentials. In the past, when a customer would contact support with an issue, the problem would be handed from one team member to another, forcing everyone to drop what they're doing and manually diagnose the problem, costing time and resources, and frustrating everyone in the process, including the customer. But with Splunk's suite of products, they can use all the data in their environment to solve the issue in less time. When the support request comes in, it's automatically routed to application support, where Caesar searches the data for events where purchase attempts ended in an error. He can then pinpoint the event that matches the user's experience. That event is tied to a database query, which can be correlated to an entry in the slow query log, allowing Caesar to escalate the issue to his admin in a matter of minutes without having to get the whole team involved. But better yet, what if we could alert when transactions fail, even before the customer calls tech support, enabling Caesar to triage the problem before it leads to bigger issues down the line? Splunk is a unified data platform that allows teams to work together or individually to ensure mission-critical digital systems stay secure and reliable. Whether you are on an IT ops, DevOps, or SecOps team, Splunk can provide the key to enterprise resilience and help build a safer digital world. Splunk's primary features make your machine data available, accessible, and usable to everyone in your organization. At the heart of Splunk is the index, which contains your machine data from sources such as servers, network devices, and web applications. Think of your indexer as a factory and your data as raw materials. As data enters, inspectors go to work. They look at the data to decide how to process it. When they find a match, they label the data with a source type. That source type is then used to break the data into single events. The timestamps are identified and normalized to a consistent format. Once data is ingested into the index, it is available for searching and analyzing. By entering a query into the Splunk search bar, you can find events that contain values across multiple data sources, allowing you to analyze and run statistics on the events using the Splunk search language. Search results can be saved to reports, which can provide continued insights into your data and can be used to power dashboard panels. Knowledge can be organized into structured datasets called data models to allow users to quickly visualize data in Pivot without having to write custom searches. To stay on top of your environment, alerts allow you to set custom triggers, so you're notified and can respond to incidents as soon as they occur. Let's take a look at the Splunk web interface. After logging into Splunk Enterprise, you will be redirected to the Splunk Home app. Apps are pre-configured environments that sit on top of your Splunk instance, extending its pre-built knowledge and capabilities. You can think of them as workspaces, built to solve a specific use case. The apps you see are defined by a user with an administrator role. Roles determine what a user is able to see, do, and interact with. There are 3 predefined default roles in Splunk Enterprise: the administrator role, the power role, and the user role. The administrator role is the most powerful, can install apps, ingest data, and create knowledge objects for all users. The power role can create and share knowledge objects with all users of an app and perform real-time searches. The user role will only see their own knowledge objects and those that have been shared with them. Similarly, Splunk Cloud ships with the roles of SC admin, power, and user, as well as additional cloud-specific roles. The Home app gives you a quick place to explore Splunk Enterprise. It allows you to launch and manage other Splunk apps, find documentation, and set a custom dashboard as your default dashboard. Admins or users with the appropriate capabilities can also add apps and data from here. Hundreds of apps are available on Splunk Base, or you can build your own. I have added a link to Splunk Base to your notes. The Search and Reporting app provides a default interface for searching and analyzing data. There are 8 main components of the Search and Reporting app's interface. The Splunk bar appears on every page in Splunk. You can use it to switch between apps, edit your account, view system-level messages, manage and edit your Splunk configuration, monitor the progress of search jobs, and find help. The app bar allows you to navigate the application. The search bar is used to run searches. You type in your search string and hit enter, or click the search icon to start a search. The time range picker is used to retrieve events over a specific time period. There is a How to Search panel with links to documentation and a search tutorial. By selecting the Data Summary button, you get a breakdown of the data indexed by host, source, and source types. We talked earlier about source types being a classification of your data. The source is the file or directory path, network port, or script from which the event originated. And the host is the host name, IP address, or fully qualified domain name of the machine from which the event originated. Table Views provides a UI-driven way to explore and prepare your data without using Splunk's search processing language. The Search History menu allows you to view and rerun past searches. We can narrow our search history by entering search terms into the filter window, and filter to show searches executed today, over the last 7 days, or over the last 30 days. Now that we're familiar with Splunk's Search and Reporting app interface, let's take a look at how we can search our data to investigate a potential security issue. Let's check in with our colleague Caesar. This morning, Caesar was killing time on his favorite social network when he got a message that there was some suspicious-looking activity on one of the Buttercup Games servers. We'll use the Search and Reporting app to help Caesar see what is happening on the server. The search bar works as you would expect it to. We just enter the information we want to search for. To see if someone is trying to log into our server using bad credentials and failing, we type failed into the search bar. As we type, the Splunk Search Assistant will display matching terms, contextual matches, and syntax documentation for the search. We only want to see when failures have happened over the last week, so we select last 7 days in the time range picker. Limiting a search by time is key to getting results faster and is a best practice to use for every search. Once that time range is selected, the search is sent to Splunk, where it becomes a search job. The new search page opens. The interface now contains a Save As menu, search result tabs, search action buttons, a search mode selector, and a timeline. The events containing the text we searched for show in the event list, and the fields that were extracted show up in the fields sidebar. The Save As menu allows us to save our search as a knowledge object. The results populate into the search result tabs depending on the type of search commands used in the search. The Events tab will display the events returned for your search, and the fields that were extracted from the events. For a simple search like this, you will usually be presented with this tab by default. The Patterns tab allows you to see patterns in your data, allowing you to get a better understanding of what is happening in your data. If your search is generating statistics or visuals, they will be displayed in the Statistics or Visualization tabs. If not, links for Instant Pivot, Quick Reports, and search command documentation will be displayed. One quick note, commands that create statistics and visualizations are called transforming commands. These are commands that transform event data into data tables. We will learn more about transforming commands in a future video. Right above the search result tabs, we see the total events returned, and an option to return a random sample of these events. The search action buttons allow us to edit, send to background, inspect, and delete search jobs. There are icons to pause, stop, share, print, or export a search job. Selecting the share icon, we get a link that we can share with others or bookmark for our own use. By default, a search job will remain active for 10 minutes after it is run. After 10 minutes, Splunk will need to run the job again to return the results. A shared search job, on the other hand, will remain active for 7 days and will be readable by everyone, meaning that anyone you share this job with will see the same exact results you did when you first ran it. The export icon will allow you to export events returned from the job in RAW, CSV, XML, or JSON formats. There are 3 search modes you can choose from the search mode selector: Fast, Smart, and Verbose. With Fast cutting down on the field information that is returned, field discovery is disabled for this mode, only returning information on default fields and fields required to fulfill your search. Verbose mode returns as much field and event data as possible, discovering all the fields it can. The default Smart mode will toggle behavior based on the type of search you are running. The timeline is a visual representation of events segmented over time. The segments are dynamically decided by the time you choose in the time range picker. In this case, we see a segment for each hour over the last 7 days. We can select a specific time range in the timeline to investigate. Doing so, our event list updates to show just the events selected. We can also use the zoom links to zoom in and out of a selection. Now that we can see the events that failed, let's look at how we can start using the events and fields to dig a little deeper. Let's take a closer look at how to use events returned by a search. When a search is run, it will return a list of events. We can use returned events to expand our searches and interact with our data. In the events list, the text we searched for is highlighted, and events are returned in reverse chronological order, showing the newest events first. While time is normalized in your index to a consistent format, the timestamp you see in the events is based off the time zone set in your user account. In this example, we see a 3-hour difference displayed for an event with a user setting of Pacific time compared to a user with a setting of Eastern time. Across the bottom of each event, we see selected fields. Currently, we have the default selected fields of host, source, and source type. Rolling over text in an event will highlight it. Clicking on the highlighted text allows you to add that text to the search, exclude events that contain that text, or launch a new search using the text. Each option has an icon that will open the redefined search into a new browser window. We add password to the search updates in the search bar, and the new events are returned. Clicking on the highlighted text again will allow you to remove it from the search. Selecting the info button next to an event, we see all the extracted fields for the event, with check marks next to the selected fields. There is a drop-down for event actions and a link for field actions. There are many options when searching terms in Splunk. If we want to cast a wider net for any text that might indicate a failure, we can use a wildcard. Adding an asterisk to the end of the text fail will return any event that starts with the word fail, including fail, failure, and failed. Search terms are not case sensitive, so no matter how we capitalize a value, all results matching the term will be returned. Uppercase booleans of and, or, and not can be used with multiple terms. So if we want to see events with the text failed, but not password, we add a boolean of not. Or all events containing the text failed or password, we use an or boolean. If no boolean is used, and is implied. Boolean operations have an order of evaluation, using not clauses first, then or, and finally and. Parentheses can be used to control the order of evaluation. As an example, by adding parentheses around the or statement in these search terms, Splunk will first evaluate the terms in the parentheses. Exact phrases can be searched by placing the terms in quotes. There might be times when you are looking for results that contain quotes. You can use a / character to escape quotes. Let's look at how to use commands to do more with our search results. Splunk's search language is built from 5 components. Search terms are the foundation of search queries. Commands tell Splunk what we want to do with the search results. This includes creating charts, computing statistics, and formatting. Functions explain how we want to chart, compute, and evaluate the results. Arguments are the variables that we want to apply to the function. And clauses explain how we want results grouped or defined. What we want to do with the search result. Splunk's search language is built from 5 components. Search terms are the search language to do more with our search results. Splunk's search language is built from 5 components. Search terms are the foundation of search queries. Commands tell Splunk what we want to do with the search results. This includes creating charts, computing statistics, and formatting. Functions explain how we want to chart, compute, and evaluate the results. Arguments are the variables that we want to apply to the function. And clauses explain how we want results grouped or defined. Clauses explain how we want results grouped or defined. Let's look at how these are put together into a search. We will talk about the specific components in a little bit, so don't worry if you don't understand what they are doing quite yet. First, we have the search terms, then the first search component. You can see that inside this stats command. And there is a function of count with an argument of usage. The as is the clause. These two search components are separated by a pipe. We use a pipe to tell Splunk to pass the current results on to the next component. Our existing query searches our web security appliance data in the network index to count the number of visits there have been to prohibited sites from our environment over the last 30 days, then stores that count in a field called visits. By appending a by clause with the CS username field, we can further split the count of these events by individual employees. The search command can be used to filter results at any time in the search pipeline. The command behaves exactly like the search terms before your first pipe, but allows you to filter your results further down the search pipeline. We can use this command with the visits field we created in the stats command to find employees that have violated our web policy more than once this month. While being able to search inside your pipeline is very powerful, remember that if you can filter the items before your first pipe, do it there for better searches. We previously discussed case sensitivity for search terms. Command names, clauses, and functions are also not case sensitive. If a command references a specific value, that value will be case sensitive. As an example, if we want to replace one of our host values using the replace command, It's required that the host value be an exact match, including case. Using time to limit the events returned is the most efficient way to filter events. The less data you have to search, the faster Splunk will be. After time, the default fields of index, source, host, and source type are the most powerful. These fields are extracted at index time, so they will not need to be extracted for each search. The more you tell the search engine, the more likely it is that you will get good results. It's better to search for failed password instead of just password. Inclusion is generally better than exclusion. Searching for access denied is better than searching for not access granted. When possible, use the or in operators instead of wildcards. Apply filtering commands as early as possible in your search. Possible, then searching for exclude instead of just. It's better to search for failed. Likely it is that you will get good results. It's better to search for failed password instead of just password. Inclusion is generally better than exclusion. Searching for access denied is better than searching for not. Access granted. When possible, use the or in operators instead of wildcards. Apply filtering commands as early as possible in your search. Filtering early limits the number of events, making future manipulations of the data faster. Knowledge objects are tools that help you and your users discover and analyze your data. Help you and your users discover and analyze your data. Knowledge objects are grouped into 5 categories: data interpretation, classification, enrichment, normalization, and search time mapping of knowledge called data models. Normalization, classification, enrichment, normalization, and search time mapping of knowledge called data models. Knowledge objects are useful in Splunk for several reasons. They can be created by one user and shared with other users based on permission settings. They can be saved and reused by multiple people or in multiple apps. And they can be used in a search. These make knowledge objects powerful tools for your Splunk deployment. These make knowledge objects and reused by multiple people or in multiple apps, and reused users based on permission settings. They can be saved and reused by multiple people or in multiple apps. And they can be used in a search. These make knowledge objects powerful tools for your Splunk deployment. Knowledge managers are responsible for overseeing knowledge object creation and usage for a Splunk deployment. Implementing best practices for naming conventions, normalizing event data, and creating data models for pivot users. Keeping the toolbox clean and efficient. Whether or not you're a knowledge manager in your environment, it's important for all Splunk users to know a little about the types of knowledge objects that exist. Let's take a quick look. Some fields are automatically extracted from data based on the selected source type, but additional fields can be manually extracted to add additional insight to your data. Calculated fields are added to events at search time and perform calculations based on the values of existing fields. Event types allow you to categorize events based on search terms. Transactions are groups of conceptually related events that span time. Lookups allow you to add other fields and values to your events, not included in the indexed data. Workflow actions let us create links within events that interact with external resources or narrow our search. Tags allow you to designate descriptive names for key value pairs. They enable you to search for events that contain particular field values. You can think of them as labels for your data. Field aliases give you a way to normalize data over multiple sources. You can assign one or more aliases to any extracted field and apply to fields from a lookup table. And finally, data models are hierarchically structured datasets, which may consist of events, searches, and/or transactions. So far, we've learned how to successfully craft searches that return the events we want. But what if we need to run the search in the future, or we want to share that search with other users? We can make a note of our searches or email them, but that could get messy and annoying. Splunk makes saving and sharing searches simple with reports. Here, we have a search that returns events containing failed login attempts. 1 or 2 failed logins may just be due to user error, but multiple failed logins may be indicative of a security incident. Our team is particularly interested in seeing where these attempts happened, but when we look at the field sidebar, we don't see anything related to geographic information. We'll append the IP location command with the source IP field to add geographic context to the returned events. Now, in the field sidebar, we see that additional fields have been added to our results. Expanding the country field, we see the top 10 values for the field, along with a count of events that contained the value, and the percentage of total events in this time period where the value occurred. At the top of this window, we see 4 links for quick reports: top values by time, rare values, or events with this field. Selecting top values appends the top command to our search and allows us to visualize this data in a bar or column chart. This is helpful, but in order to really understand where these attacks are coming from and see if there might be any trends in related areas, we'd like to visualize our results on a map. We'll replace our top command with a geostats command, which allows us to use the context provided by the IP location command to plot our data on a cluster or choropleth map. Hey Caesar, should web administrators be logging in from these locations? In order to easily share access to this data with our colleagues, we'll save it as a report by opening the Save As menu and selecting Report. In the Save As Report dialog, we enter a name, optional description, confirm that we want to display this data in a visualization, and select whether to display the time range picker or not. Before saving reports, it's best for your organization to define a naming convention. This will help keep your reports organized and easy to find. We use a naming convention of the group the report is for, the type of object it is, and a simple description of what the report contains. After saving, we are given a list of additional settings, but let's just view it for now. When a report is run, a fresh set of results is returned. Since we chose to show a time range picker, we can change the time range of the events shown. You can access all your reports from the Reports tab in the application menu. You can run the report by selecting its title, or open it in Search. Or in the application menu. You can run the report by selecting its title, or open it in Search. Selecting the arrow next to the name of the report expands to show details such as who created it and the app it was created in, as well as additional settings for scheduling or accelerating the report, and who has permission to view it. Edit links for these settings are available next to each setting, and can also be found by expanding the Edit menu. Here, you have options to edit description, permissions, schedule and acceleration, along with links to clone, embed, or delete the report if we have the proper permissions. When a report is created, it is set to display only for the owner who created it. By changing this display setting to App, we can share this report with all other users of the app in which it was created. In this, for the owner who created it. Permissions, schedule and acceleration, along with links to clone, embed, or delete the report if we have the proper permissions. When a report is created, it is set to display only for the owner who created it. By changing this display setting to App, we can share this report with all other users of the app in which it was created. In this case, search and reporting. By default, the option to display a report in all apps is only available to users with an admin role. Power users are granted read and write permissions on the report. Notice the Run As dialog. This allows the report to either be run as the owner of the report or as the user that is running the report. So if you have sensitive materials that not all users of your organization should see in the report, and the report is run as owner, the data could be returned to the user. If the report was run as user, only the data they have access to would be shown. We can schedule the report to run at timed intervals using the Edit Schedule link. There are multiple benefits to scheduling a report. We can schedule the report to run at timed intervals. Using the Edit Schedule link. There are multiple benefits to scheduling a report. It can reduce strain on your environment caused by repeatedly running new ad hoc searches. This is particularly beneficial when a report is shared with a number of users or embedded in a dashboard. Reports can be configured to run every hour, day, month, or week, or you can tune them even more by defining a cron schedule. We see a warning at the top of the schedule window for this report, letting us know that scheduling a report will override our Run As settings and will remove the time range picker from the report, since the intention is to restrict how often the report will run and what data it will access. We can specify a time range and give it a schedule window in case there are multiple concurrent searches scheduled to run at the same time. Trigger actions can further enhance your report's functionality, delivering scheduled search results via email, using a webhook to post results to an external URL, or custom scripts defined by your organization. Sometimes a visualization will help you use your data to tell a better story. Splunk allows you to visualize your data in many ways. Any search that returns statistical values can be viewed as a chart. Now that we know where our failed logins are coming from, let's investigate further and figure out what accounts are associated with those events. We'll start with the same search terms we previously used to create a report. Expanding the user field in the field sidebar, we'll again use the Quick Reports option to find the accounts most commonly experiencing login failures. This appends the top command to our search, allowing us to visualize the results. Hovering over a segment of a chart will display statistics for the segment. There are many types of visualizations in Splunk Enterprise, so you can find the right chart for your data and format it to best tell your story. The Visualizations tab contains options to select a visualization that best fits our data or customize it using the Format menu. We'll display these results in a pie chart. The top command defaults to display the 20 most common values for a supplied field. 20 looks a little crowded in this visualization, and we want to make sure we're focusing on our most common offenders. So we'll change the number of results returned to 10. There we go, much easier to read. We'll share these results with our colleagues by saving it directly to a dashboard. Expanding the Save As menu, we have the option to save this visualization to a new or existing dashboard. We'll select New dashboard, then give it a name. We have the option to add a description and can set permissions to allow others to view our dashboard. We'll leave this as private for now while we're still developing it. Splunk offers two different frameworks for building dashboards: Classic Dashboards or Dashboard Studio. We'll touch on the differences a little later, but for now, let's select Classic Dashboards. We give the panel a title and confirm that we want to display our results as a visualization and not a statistics chart. Under Advanced Panel Settings, we see that this panel is powered by the inline search we just ran, and that drill down is not enabled for this dashboard panel. Drill down behavior can be configured to make your dashboards interactive, allowing users to explore data beyond just what they see in the default dashboard view. This setting can be modified in the dashboard editor once the dashboard has been created. Our settings look good, so we save and view the dashboard. Let's add some more panels to our dashboard to tell a more comprehensive story. Returning to the new search page, we'll again search for the terms we used to visualize our most common users experiencing login failures. Let's look at events by time, so that we can see if there are any concerning spikes in login attempts. While failures are our primary concern, a spike in accepted login attempts can also hint at a potential security incident. So we'll delete the failed password requirement to return all events related to login activity. In the field sidebar, we expand the action field, where we can confirm we're now seeing results from both failures and successes. Selecting the top values by time quick report appends the time chart command to our search, so we can visualize our data as a line chart, allowing us to quickly see login trends over time. This looks good, but before we save it to our dashboard, we'll make a couple of visual modifications. Options in the Format menu will differ based on the visualization type. For example, if we change this visualization to a column chart, in the General tab, we see that we have options to change stack mode, offering different ways of thinking about how our failed and successful logins compare to one another. For our line chart visualization, we have some general settings, format options for the X and Y axis, a chart overlay option if we want to compare values from a different field, and options for our legend. We'll change the legend's position to move it to the left side of the visualization. We'll also choose to display values for our minimum and maximum data points. Now we'll save this panel to our existing dashboard and view our progress. Looking good. Additional panels can be added to our dashboard by selecting Edit, then Add Panel. In the Add Panel window, we have options to create a new visualization from scratch without returning to the search window. Add a panel from a report, clone a panel from another dashboard, or add a pre-built panel. Let's add a panel containing our cluster map visualization inside the report we previously created. We'll select New from Report, then select the report's title. A preview of the visualization is displayed, along with the details of the report and the underlying search that powers it. When we select Add to Dashboard, the panel is added to the bottom of the dashboard. Our dashboard is starting to tell a story, but could use some visual optimization. We'll move our cluster map displaying failed login attempts next to the pie chart displaying attempts by user, and change its name to be a little more human readable. While in edit mode, we also have options to see and edit the XML source for our dashboard, add inputs, and select a dark theme for our dashboard. We also have tools on each panel allowing us to edit searches, change visualizations, and modify visualization formats, along with other actions. In the drill down editor, we can configure behavior when users interact with a visualization. linking to search, another dashboard, a report, custom URL, or manage tokens for more advanced drill down capability. Let's link this visualization back to its search, save the dashboard, and refresh the dashboard to ensure that the changes have been applied. Now when we select a slice of our pie chart, a search window opens that contains the events related to that user, with the selected user already populated in the search. And of course, we can access all of our dashboards by selecting the Dashboards tab. When we created our dashboard, we had the choice of one of two frameworks: Classic Dashboards and Dashboard Studio. Using our existing dashboard, let's take a quick look at the features of Dashboard Studio. Navigating to the Dashboards tab, we open our existing dashboard. Expanding the menu at the top right corner of the interface, we select Clone in Dashboard Studio. We see the same options we had when creating a classic dashboard, to change the name and optional description of the dashboard, as well as define its permissions. Now we need to decide whether we want our dashboard to be in absolute or grid mode. Absolute layout offers pixel-perfect, fully customizable placement, while the grid layout offers automatic snap-to alignment to quickly organize your panels into rows. We'll select grid layout, then convert and save. The dashboard opens in edit mode. Icons at the top contain controls to add a new visualization, add inputs, add markdown text, show or hide the configuration panel, configure data sources, or edit the dashboard's JSON definition. The options available in the configuration panel will vary depending on the selected visualization. While the width and height of panels can be defined in classic dashboards by editing the XML source, Dashboard Studio makes it easy to customize your dashboard layout by selecting and dragging the boundaries of dashboard panels. Since we created this dashboard in grid mode, all neighboring panels adjust accordingly. Looking at a side-by-side comparison of each layout, both have their strengths. Grid layout offers a quick and easy-to-use experience, with many visualization charts and limited canvas customization. The absolute layout offers a highly customizable canvas with pixel-perfect control. It has options like background color or image and canvas size, as well as the addition of shapes, icons, and additional images up to 16 megabytes. Thank you so much for joining us to begin your journey learning about Splunk. For getting started guides and product tips, please visit Splunk Lantern. We also suggest you check out the documentation, visit our Splunk How-To YouTube channel, and register for additional courses from Splunk Education. Thanks for watching.
Let's see if we can remember. Terms failed password or failed password. Has it been failed or password or this? Failed or password or failed password. This is going to be and then this is going to be or. So we want this. Oh, I'm gonna know at the end. Okay, let's see. Further filter results in a search, filter subsearch search. Oh shoot, I don't remember this one. Further filter? I think filter, subset, subsearch. I remember something about subsearches. Default roles. Dang, I gotta go back and take some more notes. Admin, user admin. Uh-oh. Power. I know there's a I don't know. I'm gonna get some of this wrong. How long does a search job remain active? Search job? I don't know, 10 minutes? Dang, I don't know these. What determines the timestamp shown on returned events? Times when the event originated, I believe. Share knowledge objects, you need to be object manager or admin, I think. Stores ingested data, an index. I totally did not do good on this. Oh, let's go. I think I gotta go back to this thing.
Let's take a look at the Splunk web interface. Object notes of ingest data, an administrator, extending its pre-built knowledge and capabilities. You can think of them as workspaces built to solve Let's take a look at the Splunk web interface. After logging into Splunk Enterprise, you will be redirected to the Splunk Home app. Apps are pre-configured environments that sit on top of your Splunk instance, extending its pre-built knowledge that sit on top of Splunk Home app. Apps are pre-configured environments that sit on top of your Splunk instance, extending its pre-built knowledge and capabilities. You can think of them as workspaces, built to solve a specific use case. The apps you see are defined by a user with an administrator role. Roles determine what a user is able to see, do, and interact with. There are 3 predefined default roles in Splunk Enterprise. The administrator role, the power role, and the user role. The administrator role is the most powerful, can install apps, ingest data, and create knowledge objects for all users. The power role can create and share knowledge objects with all users of an app. The power role can create and share knowledge objects with all users of an app and perform real-time searches. The user role will only see their own knowledge objects and those that have been shared with them. Similarly, Splunk Cloud ships with the roles of SC admin, power, and user, as well as additional cloud-specific roles. And user, as well as additional cloud-specific roles. The Home app gives you a quick place to explore Splunk Enterprise. It allows you to launch and manage other Splunk apps, find documentation, and set a custom dashboard as your default dashboard. Admins or users with the appropriate capabilities can also add apps and data from here. Hundreds of apps are available on Splunk Base, or you can build your own. I have added a link to Splunk Base to your notes. The Search and Reporting app provides a default interface for searching and analyzing data. There are 8 main components of the Search and Reporting app's interface. The Splunk bar appears on every page in Splunk. You can use it to switch between apps, edit your account, view system-level messages, manage and edit your Splunk configuration, monitor the progress of search jobs, and find help. The app bar allows you to navigate the application. The search bar is used to run searches. You type in your search string and hit enter is used with links to documentation. You get a brief about source or script, IP address, or fully qualified domain name of the machine without source types being a source how to search panel with links to documentation and a search tutorial. By selecting the data summary button, you get a breakdown of the data indexed by host, source, and source types. We talked earlier about source types being a classification of your data. The source is the file or directory path, network port, or script from which the event. Table Views provides a UI-driven way to explore and prepare your data without using Splunk's search processing language. The Search History menu allows you to view and rerun past searches. We can narrow our search history by entering search terms into the filter window, and filter to show searches for the last 30 days. Now that we're familiar with Splunk's Search and Reporting app interface, let's take a look at how we can search our data to investigate a potential security issue. Let's check in with our call. There was some server using bad credentials over the last a search mode select. The Events tab will display the events searches generated buttons allow us to note. Commands that create statistics and visualizations are called transforming commands. These are commands that transform event in a future video. In or after by everyone. Active for a shared search job, on the other hand, will remain active by default. A search job will remain active for 10 minutes after it is run. After 10 minutes, Splunk will need to run the job again to return the results. A shared search job, on the other hand, will remain active for 7 days and will be readable by everyone, meaning that anyone you share this job with will see the same exact results you did when you first ran it. The export icon did when you first ran it. Anyone you share this job with will see the same exact result. Everyone will remain active for 7 days and will be readable by everyone, meaning that the export icon will allow you to export events returned from the job in RAW, CSV, or 3 search modes you can choose from the search mode selector. Fast, smart, and verbose. With fast cutting down on the field information that is returned, field discovery is disabled for this mode, only returning information on default field and fields required to fulfill your search. Verbose mode returns as much field and event data as possible. Discovering all the fields it can. The default smart mode will toggle behavior based on the type of search you are running. The timeline is a visual representation of events segmented over time. The segments are dynamically decided by the time you choose in the time range picker. In this case, we see a segment for each hour over the last 7 days. We can select a specific time. Now that we can see the events that failed, let's look at how we can start using the events and fields to dig a little deeper. Let's take a closer look at how to use events returned by a search. When a search is run, it will return a list of events. We can use returned events to expand our searches and interact with our data in reverse chronological user account, showing the newest events first. First chronological order. Showing the newest events first. While time is normalized in your index to a consistent format, the timestamp you see in the events is based off the time zone set in your user account. The timestamp you see in the events is based off the time zone set in your user account. In this example, we see a 3-hour difference displayed for an event with a user setting of Pacific time compared to a user with a setting of Eastern time. Across the bottom of each event, we see selected fields. Currently, we have the default selected fields of host, source, and source type. Rolling over text in an event will highlight it. Clicking on the highlighted text allows you to add that text to the search, exclude events that contain that text, or launch a new search using the text. Each option has an icon that will open the redefined search into a new browser window. We add password to the search updates in the search bar, and the new events are returned. Clicking on the highlighted text again will allow you to remove it from the search. Selecting the info button next to an event, we see all the extracted fields for the event, with check marks next to the select event actions. There are many options when searching terms in Splunk. If we want to cast a wider net for any text that might indicate a failure, we can use word, multiple child, or password. We use an or boolean. If no boolean is used, and is implied. Boolean if filled boolean see events with the text used with multiple terms. So if we want to see events with the text failed, but not password, we add a boolean of not. Or all events containing the text failed or password, we use an or boolean. If no boolean is used, and is implied. Boolean operations have an order of evaluation, using not clauses first, then or, and finally and. Parentheses can be used to control the order of evaluation. As an example, by adding parentheses around the or statement in these search terms, Splunk will first evaluate the terms in the parentheses. Exact phrases can be searched by placing them in the parentheses. The or parentheses can be used to control the order of evaluation. As an example, by adding parentheses around the or statement in these search terms, Splunk will first evaluate the terms in the parentheses. You can use a backslash character to escape quotes.
This platform kind of jank. What is the difference between e-learning and this? Oh, it's instructor-led? I see. Yeah, nah. Wait, if this is 3 hours? Alright, so let's say I do this today. Hold on. Oh, it doesn't say. Oh, this one's 1 hour. What is this? Equivalence? I don't know what that has to do with anything. Now it says 3 hours, but this one says 1 hour. Okay.
Hello, welcome to the Using Fields Learning module. I'm Chris with Splunk Education. In this module, Jessica and I will help you learn how to use fields to filter your data to return the results you need. We will learn how to use fields in Splunk's search processing language, as well as the Splunk user interface to further filter your data, which fields are extracted from your data at index versus search time, the difference in persistent and temporary fields, and how to do more with your data through the use of knowledge objects. The field sidebar shows all the fields that were extracted at search time. We see the fields are fields of the utmost importance to you. They show up at the top of your fields list and at the bottom of your events. They show up at the top of your fields list and at the bottom of your events. The default fields host, source, and source type are selected by default. Interesting fields are fields that have values in at least 20% of the events. The letter A next to a field denotes a string value. A hash mark denotes a numeral. Clicking on a field, you will see a list of values for the field, a count of the values, and a percentage of the events the value shows up in. You can add a field value pair to your search by clicking on it. Launch quick reports based on the field, and add it to the selected fields list. The available quick reports will be different depending on the returned values, but clicking on one will create a transforming search and display your results as statistical data. When you add a field to the selected fields list, the field will show in the events where it occurs and persist for subsequent searches. You can see all fields for the search by using the All Fields link at the top of the fields list, or the More Fields link at the bottom. From here you can filter fields, see number of values, coverage, type, and add a field to the selected fields. You can refine and run more efficient searches by using fields in them. In this example, we're getting events from 3 different source types. We want to limit events returned by looking only at the Linux Secure source type for now. Searching for a field of source type with the value of Linux Secure returns only those events. Field names are case sensitive, while values are not. The operators equal and not equal to can be used with fields of numerical or string values. While greater than or equal to, less than, and less than or equal to operators can be used for fields with numerical values. Fields can also be added to your search by clicking on a value in a fields window. We can see that our mail server host has returned some events. To focus just on our web servers, we can add a not equal operator to a field value pair in our search. As you can see in this search, wildcards can also be used with field searches. We can also use booleans with field value pairs. By removing the is not equal, operator and adding a boolean of not, Splunk returns the same results. Here we are nesting search terms in parentheses to return events that are not from mail or www1 hosts. For fields containing an IP address, wildcards are subnet and CIDR aware. It's important to understand the difference between the not equal to field operator and the not boolean. They will not always return the same results. As you can see in these example searches, the number of events returned is wildly different. The top search is only returning events where the status field is not 200, while the bottom search returns all events that do not have a field where status equals 200. Meaning, all events that do not have a field where status equals 200. Meaning that if an event does not have a status field at all, it will be included in the results. As an alternative to chaining together several operators, Splunk can also use an in operator. It's used following a field name, with the values we are wanting to include in our results wrapped in parentheses. The fields command can be used to include or exclude fields from your search. Here, we've piped our previous search into a stats command to create a table that displays a count of events by their status. Since the only field values we're using belong to the status field, we can make our since the table here we to include or exclude fields from your search. Here can be used to the fields command can be used to include or exclude fields from your search. And can be used to include or exclude fields from your search. Here, we've piped our previous search into a stats command to create a table that displays a count of events by their status. Since the only field values we're using belong to the status field, we can make our search more efficient by adding a fields command, followed by the field to include in the search. Filtering as early as possible in a search is a best practice, so we place this command before the stats command. The fields command uses a plus or minus operator to specify whether a field should be included or excluded. This command defaults to inclusion, so if no operator is specified, the supplied fields will be included in the search. The rename command can be used to rename fields in your search, to give them more meaningful or user-friendly names. Our column headers of status and count are default labels from our field name and our stats command, but some employees in our organization might not find these labels descriptive enough. We pipe to the rename command and supply the field name with an as clause, followed by the new field label. Since this label is a phrase, we wrap it in quotes. We can rename multiple fields with the same command by separating them with a comma. Employees in our organism with a comma. Let's take a look at how Splunk returns fields in search results. We've mentioned that some fields are extracted at index time, while others are extracted at search time. But what does that really mean? When Splunk ingests data into the index, a select number of fields are automatically extracted. These include metadata fields such as host, source, and source type, and internal fields such as time and raw, which contain the event's timestamp and the original raw data of an event. At search time, Field Discovery extracts additional fields from raw event data. Splunk will automatically extract fields from your data based on its assigned source type, as well as key value pairs found in the data. These fields are persistent and will be extracted every time a search is run containing the same search terms, unless you explicitly tell Splunk to not return them. Temporary fields can also be created on an ad hoc basis using commands such as eval. The eval command is used to calculate and manipulate field values. Results of eval commands can be written to a new temporary field at search time, or replace an existing field's values. Let's look at an example using data from the fictional gaming company Buttercup Games. After an initial search of what sites were being misused during business hours, they have added a new web access policy. The usage is broken down into categories of usage types. The boss wants us to query this data to calculate how much internet bandwidth is being used for each usage type. We first use the stats command to find the sum of all bytes used. The resulting report shows the number of bytes used as bytes. This is what we asked for, but converting these values to megabytes would make our report much easier to understand. A web search tells us that a megabyte is 1024 to the power of 2 bytes. So we pipe our search into an eval command that divides the bytes by 1024, then divides the result by 1024 again. Since we used a non-existing field name for the results, a new field of bandwidth is created. The field extractor utility can be used to extract fields from your data that were not automatically extracted for its assigned source type. You can also use commands to extract fields that were not extracted at search time. These commands extract fields from your data using regular expressions, or regex. If you're inexperienced with regex or would like a refresher in its syntax, we recommend you watch our regex overview video. I have added a link to it, as well as the Splunk documentation, to your notes. Now let's hand it over to Jessica to teach us about the erex and rex commands.
While fields extracted with the field extractor are persistent across searches, there might be times where you want to extract values temporarily for the duration of a search. Splunk provides the erex and rex commands for this. The erex command is a lot like automatic field extraction in the field extractor. You give it a sample of values and Splunk will try to extract what you want. In the game beta logs, we see unextracted data representing character names for our users. We pipe our search into the erex command. Provide a field name to use for the extracted values. Use the from field argument to tell Splunk which field in our data to match on. And use an argument of example.
Splunk it, Splunk it.
Samples to provide a list of sample data. When the search is run, Splunk builds a regular expression based on the sample data, checks it against the raw event data, and adds matched values to the character field. While the erex command is very handy when you need to get quick results, it can suffer the same issue as automatic field extraction. It only knows what to look for based on the sample you have given it. Using the where command with the isNull function, we can see some character names were missed. Adding more samples to the examples argument will fix this. we can see the regular expression Splunk used to match by clicking on the Jobs menu. Like with the field extractor, EREX is a great way to start your regex, but should be checked and edited to match your needs. Information in the Job menu suggests using the rex command with the generated regex. The rex command allows you to use regular expression named capture groups to extract values at search time. It can be used on field values or raw data. The rex command allows you to match multiple groups, resulting in multiple fields. Let's extract both the user and character name values from our game beta data. Here we are using the field of _raw as the field to match on. By default, this field will be used if no field argument is given. Note that running rex over the raw field can have a performance impact. If you already have an extracted field that you can use, always default to using it. We enter a regular expression that we created earlier inside double quotes and run the search. We now have a field of user that includes the email addresses. We continue our expression to return a character field. Behind our capture group, we add an apostrophe, followed by a \s to match the whitespace. To match character name, in our data, we add a character class of upper and lowercase letters and a colon. We use a plus quantifier to match all characters within the class, followed by an apostrophe. We create another capture group named character. Inside this group, we will match one or more of a character class that includes upper and lowercase letters, digits, along with period and dash symbols. Upon running the search, we now have both user and character fields available to us. When choosing to use EREX versus rex, keep a few things in mind. EREX is easier to use. You do not need to know regex to use EREX, where rex requires it. With EREX, you need to provide samples to generate regex. Rex does not require sample data. EREX creates a regular expression for you. You can use these expressions as a starting point with rex. When possible, use rex.
We previously used the eval command to create temporary fields at search time. This command takes the value contained in the bytes field, divides it by 1024, twice to convert it to megabytes, and stores it in a new field called bandwidth. This calculation made our search results much easier to read, but since this is not a persistent field, we will have to manually type out the eval command every time we want to make the conversion, which is not very efficient. Thankfully, there's a better way. By storing this eval command in a calculated field, Splunk will automatically create the field at search time every time a search containing the bytes field is run. There's one thing to keep in mind when creating a calculated field. Calculated fields can only reference fields that are already present in the events returned by a search. In the search we ran earlier, the bytes field is created by another command in the search. For calculated fields to perform correctly, make sure they are configured to reference a field that has already been extracted. Field aliases allow you to assign alternate names to fields in your data. If you have fields from multiple source types, such as user and username, that all contain similar values, you can create a field alias so that the similar values are grouped together. This allows you to search for all values at once in the shared field alias. Field aliases do not replace or remove the original field name, so you can search your data using either the original name or its alias. Lookups allow you to add other fields and values to your events that are not part of the index data. These field value pairs can be configured not part of the lookups allow you to add other fields and values to your events that are not part of the index data. These field value pairs can be configured to automatically append to events in your search at search time, allowing you to add related information to lend additional search at search time. Value pairs can be configured to automatically append to events in your search at search time, allowing you to add related information to lend additional context to your data. It's important to remember the search time operations order when working with knowledge objects related to fields. Field extractions are evaluated first in the pipeline, followed by field alias field extract order when it's important to remember the search time operations order when working with knowledge objects related to fields. Field extractions are evaluated first in the pipeline, followed by field aliases, calculated fields, then lookups. This means that calculated fields can add additional context to extracted fields, since they are evaluated third, but a field alias cannot reference a value from a lookup. Creating knowledge objects is out of the scope of this learning module, but I have added a link to additional modules from Splunk Education, as well as the documentation to your notes. It has been a pleasure to join you on your journey to learning about Splunk. We suggest you check out the documentation and register for additional learning modules from Splunk Education. Thanks for watching. Hello, I'm Chris with Splunk Education. In this module, we'll look at how to use scheduled reports and alerts to better automate processes in your deployment. We'll begin with scheduled reports. A scheduled report is a report that runs on a scheduled interval. Every time a scheduled report is run, it can automatically be sent by email or trigger additional actions. They can also be used to power dashboard panels to prevent Splunk from running multiple concurrent ad hoc searches. Meet Dan, a sales employee from the fictional gaming company Buttercup Games. Every Monday, he needs to report on the previous week's product sales numbers in order to monitor the progress his team is making with the new sales strategy. Rather than run this report manually every time, he would like to set it up to run automatically. A scheduled report is the perfect solution for Dan's reporting needs. To create our scheduled report, we first start with a search we want the report to be based on. From the Save As menu, select Report. Give the report a name. We also have the option of adding a time range picker to the report. Since this report will be scheduled, there's no reason to include the picker. After we create our report, we select the Schedule option from the Additional Settings links. The Edit Schedule window now opens. Select Schedule Report and the frequency to run the report. For our sales report, Dan needs it to run every week on Monday at 6 a.m. Then we select the time range that the report will cover. Typically, the time range is relative to the schedule. Since we need to run the report every week, we set our time range to return events from over the last 7 days. Running concurrent reports, and the searches behind them, can put a demand on your system hardware, even if everything is configured to the recommended specs. Splunk has settings that allow us to set schedule priority for scheduled searches and set a time window that they may run in. These help us manage our scheduled reports so that they put less strain on our deployment. Schedule priority is only available to admin users and allows us to choose between default, higher, and highest. Giving a scheduled report a greater priority will make sure that they take priority over other searches being run on the system at that time. The schedule window settings allow us to set a time frame in which to run our report. So, if we have other reports scheduled to run at the same time, we can provide a window in which to run a report. This provides some timing flexibility as to when the report is actually executed. If the system is busy, our report will be delayed as long as it falls within our acceptable window. You would include a schedule window only if the report doesn't have to start at a specific time and you're okay with the delay. Setting the window to auto will allow Splunk to automatically determine the best time window in which to run the report. Next, we can choose what actions to trigger when a scheduled report is run. There are options for logging an event to a Splunk receiver endpoint, outputting results to a lookup, sending results to a telemetry endpoint, running a script, sending an email, and posting to an external URL. Splunk also lets you install or build custom alert actions depending on your user role. Admin users will have the option to manage and add pre-built alert actions by selecting Manage Actions. We have added a link in your notes to courses and documentation on building your own actions. Dan would like to receive this report via email, so we will add that trigger action to the report. We select Send Email. This is configured by entering one or more addresses in the to field separated by a comma. We set the priority and can customize the subject and message sent in the email by using tokens. Here we are supplying the name of the report, but there are many tokens that can be used. I have added a link in the notes to documentation on the available tokens. There are options of what to include in the email. These include links to the report and results, search string run, and documents to attach. We have the option to send the email in HTML and/or plain text format. Clicking Save, our report is scheduled, and Dan will start getting his report first thing every Monday morning. Managing scheduled reports can be done from the Searches, Reports, and Alerts link in the Settings drop-down menu. We get a quick overview of our report, including when it is scheduled to run next. Clicking the name of the report, we get quick access to change the search string and time range. The Edit action next to the name of our report allows us to edit the search, permissions, schedule, acceleration, and summary indexing for the report. We can also disable, clone, embed, move, or delete our report. We can also access report management from the Reports tab in the Search and Reporting app. Clicking on the name of the report in this window will display the results of our scheduled report. We can use the Edit button to change settings from this location. Users with a power role have the option to display this report for themselves or other users of the app. In this case, search and reporting. Displaying a report for all apps requires an admin role. Selecting app allows us to grant read and write access to all users in our organization or users based on their role. Dan would like to make this report available to folks at Buttercup Games that do not have access to the Splunk instance. We can do this by using the Embed option. Clicking on Edit and then Embed, we can enable embedding for the report. Please be very cautious when doing this. An embedded report will be viewable by anyone that has access to the web page that it is inserted in. We click Enable Embedding and are given the code for an iframe that we can use on any HTML page. Please note that an embedded report will not show data until the scheduled search is run. Once embedding is enabled, we will no longer be able to edit attributes for the report. There's also an option to add a scheduled report to a dashboard.
Wait, what? Did I just miss this? Wait, was I not paying attention to this at all?
Splunk alerts are based on searches that
Wait, what? Am I tweaking?
attributes for the report. There's also an
Yeah, it just entirely skipped that. What the heck?
that run on a scheduled. Splunk alerts are based on searches that run on a scheduled interval or in real time. You can have Splunk alert you when the results of the search meet a defined condition. Alerts are triggered once the search is completed. Based on your needs, alerts can list in the Splunk interface, log the event, be outputted to a lookup, send to a Splunk interface completed. Based on your needs, alerts can list in the Splunk interface, log the event, be outputted to a lookup, send to a telemetry endpoint, run scripts, send emails, use webhooks, or run a custom alert. Run scripts, send emails, use webhooks, or run a custom alert. We create an alert by first defining a search. We are going to search for any 500 errors on our web servers. From the Save As link, we choose Alert. We enter a title. Next, we set the alert permissions. We can choose between private and shared in app. When set to private, only you can access, edit, and view the alert. When shared in app is selected, the results will be displayed for all users of the app. By default, everyone has read access and power users have write access to the alert. There are two alert types to choose from, scheduled and real-time. A scheduled alert type allows you to set a schedule and time range for the search to be run. There are two. One has read will be displayed for all users alert. When shared in app is selected, the results will be displayed for all users of the app. By default, everyone has read access and power users have write access to the alert. There are two alert types to choose from. Scheduled and real-time. A scheduled alert type allows you to set a schedule and time range for the search to be run. You can select from a predefined time range or use a cron expression. The real-time type will run the search continuously in the background. As soon as alert conditions are satisfied, an action is triggered. Since real-time alerts run continuously, they can place more overhead on system performance. We would like to know as soon as our trigger condition is met, so a real-time alert type is a better fit. Next, we set the trigger condition that will cause our alert to fire. You can set alerts to trigger per result, after a defined number of results, after a defined number of hosts are returned, after a defined number of sources are returned, or with custom conditions you define using the Splunk search language, turned, or with custom conditions you define using the Splunk search language. Since many issues may lead to a 500 error on a web server, like a bump in the network or a server update, we would like to confirm a problem before sending an alert. For this, we select the problem before sending a network or a server update. We would like to confirm a problem before sending an alert. For this, we select the number of results trigger condition. We want to be alerted if an error is returned more than once, so we select greater than from the dropdown and enter 1 for the number of results. We then select the time range for the events to happen in before triggering the alert. We set the alert to trigger if more than one error happens within 60 minutes. Because alerts are so incredibly useful, it could be easy to inundate users with alerts, allowing them to be ignored or filtered out. To help keep this from happening, we can set the number of times to trigger the alert using the trigger setting, and throttle how often the alert is executed. If we select the option to trigger the action once, the action will only be fired once within the scheduled time we have selected. If we select for each result, it will be fired every time our conditions are met. As an example, our alert is set to trigger every time 2 or more errors happen within 60 minutes. If we have 6 errors happen in that 60 minutes, we will get 5 emails if we select actions for each result. We will only get 1 email if set to once. We can make these settings more granular using the throttle checkbox. Here, we can suppress based off of field values or time intervals. We create an alert by first we can suppress based off of field values or time intervals. Alert actions allow you to respond to triggered alerts. Alert actions allow you to respond to triggered alerts. Continuing to edit our current alert, we select the actions we want to happen when the trigger conditions are met. We have a choice of actions to take when an alert is triggered. The options will be a little different depending on user role. The Triggered Alerts action allows us to set the severity of the alert, which allows us to sort and filter alerts in the Triggered Alert list. If you have proper capabilities, you can use a log event action. Log events are sent to your Splunk deployment for indexing. We enter the event information that will be written to the log, the source type, and host for the alert, and the target index for the log event. The output results to a lookup option will create or update a CSV lookup table. We can choose to append or replace the data in the lookup table. Using the output to telemetry endpoint allows us to set a name, input field, select the data type, set categories, and opt in. The Run a Script action will trigger a shell script or bash file stored on your instance. This action is officially deprecated, and we suggest using a custom alert action instead. With the Send Email action, you can set where to send email, priority, subject, message, what elements to include, and to send in HTML and/or plain text. You can use Splunk tokens to add dynamic data to the email. Webhooks allow you to define custom callbacks on a particular web resource. For instance, you can set up a webhook to make an alert message pop up in a chat room, or create a ticket in a support app. Splunk also allows you to install or build custom alert actions. We choose event. The output results to a lookup option will create or update a CSV input field. The Run a Script action, officially deprecated email action, message or plain text. You can use Splunk tokens to add dynamic callbacks on a particular. Webhooks allow you to define custom callbacks on a particular web resource. For instance, you can set up a webhook to make an alert message pop up in a chat room, or create a ticket in a support app. Splunk also allows you to install or build custom alert actions. Admin users can find pre-built alert actions by clicking the Manage Alert Actions link. If there's not an action that fits your needs, you can build your own. I have added a link to the alert actions available on Splunkbase and documentation on creating your own. We choose to use a triggered alert, click Save, and view the alert. Since we elected to have alerts listed in triggered alerts, we can see any time an alert was triggered by going to Triggered Alerts in the Activity menu. From here, we can view the results and edit the search that defines the alert. We can manage alerts the same way we did scheduled reports by accessing the Settings and Searches, Reports, and Alerts links. Alerts can also be viewed and edited from the Alerts menu in the Search and Reporting app. On the Alerts page, we can see an alert's title, available actions, the owner of the alerts app, who the alert is shared with, and whether the alert is enabled or disabled. Additional information about an alert can be viewed by expanding it, and we have direct links to edit permissions, settings for the alert type, trigger conditions, and alert actions, provided we have edit permissions for the selected alert. We can open this alert in Search, or use the Edit menu to edit the alert, edit permissions, disable, clone, or delete it. The Edit Permissions dialog should look familiar, as it contains the same settings we saw when editing permissions on a report. Alerts are private by default, but can be displayed for all users of the app, or in all apps. Allowing all apps to display an alert requires an admin role. Selecting app allows us to grant read and write access to all users in our organization or users based on their role. It has been a pleasure to join you on your journey to learning about Splunk. We suggest you check out the documentation and register for additional learning modules from Splunk Education. Thanks for watching. Hello, welcome to the Visualizations Learning module. I'm Chris with Splunk Education. In this module, you'll learn how to visualize and format your data into tables and charts using Splunk's search processing language commands as well as the Splunk web interface. Let's begin by learning how to use some basic formatting commands. The Fields command allows you to include or exclude specific fields from search results. This can be handy when you need to limit the fields displayed and can make a search run faster. To include a field, we pipe our search terms into the Fields command. With the fields we want to include as the arguments. As you can see, this search returns only the field's product name and price. To exclude a field, we use a minus sign between the Fields command and the field names. When this is done, the product name and price fields are removed from the fields list. In our search, there's a space between the minus operator and the field names. This causes all field names to be affected by the operator. If we remove the space, the operator only affects the field directly behind it. When we run this search, we see that only the price field remains. The Fields command defaults to inclusion, so while our product name field will be removed, a lack of operator tells Splunk to only include the specified field. Internal Splunk fields like raw and time will always be extracted, but you can remove them from the displayed results by using the fields minus command. Field extraction is one of the most costly parts of search. Since field inclusion occurs before field extraction, limiting fields extracted can make your searches more efficient. The table command is similar to the fields command. The table command is similar to the fields command in that specified fields are kept in your results. The table command is different in that it is a transforming command that retains the data in a tabulated format. By entering the table command followed by session ID, product name, and price fields, we get an easy-to-read table. This table shows which products a user session successfully purchased and for what price. Column headers are field names, rows are values, and each row represents an event. Columns are in the order given in the arguments. To rearrange columns, all we do is change the order of the arguments. The fields command can be used with the table command to improve the efficiency of this search. Since our goal is to return a table that only uses the session ID, price, and product name fields, we can add the fields command to limit our search to just return these fields. If we exclude any of the required fields before piping to the table command, Splunk is unable to display that field's values in the table. You can use the dedupe command to remove duplicate events from the results that share common values. First, let's add our session ID field back to the fields command so that our table displays correctly. That's better. In our table, we see what appear to be duplicate events. These events represent multiple actions a user has taken in our web store over the session, such as viewing a product, adding it to their cart, and purchasing it. For the purposes of this table, we do not need these duplicate entries, so we will pipe to a dedupe command with the unique session ID values. So each session is only represented once. You can filter your results based on a single field, or for a combination of values among several fields. When using the dedupe command, it's important to supply the correct field names for the events you wish to display. If we remove the JSessionID field and only dedupe on the price field, we limit our table to just one event per price value, which is not the result we were looking for. The addTotals command by default will compute the sum of all numeric fields for each row and create a total column. We have been asked to create a table displaying retail sales for each product sold in the United States and Canada over the last 7 days. We pipe to a chart command to calculate the total sum of all purchases for each unique product per country. Let's take our search and pipe to the addTotals command. We see that Splunk has added a total column containing the sum of the rows. We can create a column summary by setting the call variable to true. Notice that the row that was created is not labeled. We add a label by setting the label variable with the name to use and the label field variable with the field to show the label in. We can change the label for our row totals using the field name variable. To remove the totals by product and only see totals by country, we can set the row variable to false. The field format command can be used if you want to format the appearance of values without making a change to the underlying raw data. For all numeric field and only values command by default is not the result we were looking for. The addTotals command by default will compute the sum of all numeric fields for each row and create a total column. We have been asked to create a table displaying retail sales for each product sold in the United States and Canada and create a total column. We have been asked to create a table displaying retail sales for each product sold in the United States and Canada over the last 7 days. We pipe to a chart command to calculate the total sum of all purchases for each unique product per country. Let's take our search and pipe to the addTotals command. We see that Splunk has added a total column containing the sum of the rows. We can create a column summary by setting the call variable to true. Notice that the row that was created is not labeled. We add a label by setting the label variable with the name to use and the label field variable with the field to show the label in. We can change the label for our row totals using the field name variable. The label for our row totals using the field name variable. To remove the totals by product and only see totals by country, we can set the row variable to false. The field format command false and only see totals by country. To remove the totals by product and only see totals by country, we can set the row variable to false. The field format command can be used if you want to format the appearance of values without making a change to the underlying raw data. To format the appearance of values, the field format command can be used if you want to format the appearance of values without making a change to the underlying raw data. Here we have a table of retail sales by product for all countries over the last 7 days. While this table contains helpful information, it's a little difficult to read. We can clean it up by using the field format command. We will overwrite the existing values in the total field by adding a $sign, then using the toString function to convert the numeric value to a string, and supply an optional argument to format it with commas. Our string function is in the total field. By adding a $sign, we will overwrite the existing values in the total field by adding a $sign, then using the toString function to convert the numeric value to a string, and supply an optional argument to format it with commas. It's important to remember that while the field format command creates new field values, the underlying data in your index does not change. All this magic happens in Splunk's user interface. Splunk allows you to visualize your data in many ways. Any search that returns statistical values can be viewed as a chart. As an example, if we take this search that returns the number of games purchased through vendors, and click the Visualization tab, we get a chart of our data. Here we see the data in a line chart, which is not very helpful. But if we change it to a column graph in the Visualization menu, things become much clearer. You can roll over the chart to see the count totals for each column, and click on a column to drill down to the events represented by the graph. Most visualizations require results structured as tables, with at least 2 columns. If we look at our search in the Statistics tab, we see with at least 2 columns. If we look at our search in the Statistics tab, we see 2 columns, also referred to as a single series. The first column provides the x-axis values, while the second column provides the y. Splunk's transforming commands order search results into a data table. That can be used for Splunk's transforming commands order search results into a data table that can be used for statistical purposes. You'll need them if you want to transform your search results into visualizations. Let's take a look at a couple of these commands. Search results into visualizations purposes. You'll search results into a data table that can be used for statistical purposes. You'll need them if you want to transform your search results into visualization. Let's take a look at a couple of these commands, starting with the top command. Let's take a look at a couple of these commands, starting with the top command. The top command finds the most common values of given fields in a results set. If we want to find which vendors have sold the most products this week, if we want to find common values of given fields in a results set. If we want to find which vendors have sold the most products this week, we pipe a search of the vendor sales source type into the top command, using the vendor field as the argument. The top command automatically returns count and percent columns and limits the results to the top 10 vendors. Returns count and percent columns and limits the results to the top 10 vendors by default. To get more or less than 10 results, a limit clause can be added. To get all results, a limit of 0 is added. You can also use the top command over multiple fields. If we add the product name field to our search, we can see the top results for both vendor and product name. Clauses can also be used with the top command to change the titles of the count and percentage columns, or to not show them at all. Titles of the count and percentage columns, or to not show them at all. And to add a row of count numbers for result, not within the limit. And to add a row of count numbers for results not within the limit. Let's search for the top 5 vendors that made the most sales this week. We do not care about the percentage, so we remove it using a value of false for show percent. Rename the count field to number of sales, and add a row for the number of sales for vendors not listed in the top 5. There might be times when you want to show top results split by another field. We can do this with a by clause. Let's say we want to search. We can do that many times when you want to show top results split by another field. We can do this with a by clause. Let's say we want to search for the top 3 products sold by each vendor in the last 7 days. Again, we'll rename the count field to number of sales. We don't need to see the percentage, so we remove that from the results. Now we can see the top 3 products sold by each vendor. The rare command has the same options as the top command, but it shows the least common values of a field set. As the top command, but it shows the least common values of a field set. So by changing the search we used for the top command to rare, we get the vendors who have sold the least amount of product this week. We can also use the by clause to return the 3 games that sold the least by each of our vendors. To produce statistics from our search results, we use the stats command. Some of the common stats functions are count, distinct count, sum, average, min, max, list, and values. Individual functions of the stats command are out of scope of this module, but I have added links to the Splunk documentation, as well as related modules to Splunk Education in your notes. To find the total number of vendor sales in the last week, we pipe a search of vendor sales into the stats command with the count function. As you can see, the count function creates a column labeled count, which is not very helpful. To change the name of the count column, we use an as clause, like we did with the rename command. To find all the vendor sales by game title, we use the by clause. The by clause returns a count for each field value of the named fields. The by clause for vendor sales by game title, we use the by clause. To find all the vendor sales by game title, we use the by clause. The by clause returns a count for each field value of the named fields. You can add any number of fields to split the count by. By adding a field as an argument to the count function, we can get a count of the number of events where the field is present. The chart command can take 2 clause statements, over and by. The over clause tells Splunk which field statements. The chart command can take 2 clause statements, over and by. The over clause tells Splunk which fields you want to be on the x-axis. Any stats function can be applied to the chart command. To see this in action, let's search our weblog for any errors, and tally how many times each type of error happens, by adding the over clause to the status field. When we look at our results as a column chart, we see status is on the x-axis with a count on the y. The y-axis should always be numeric, so that it can be charted. The by clause comes into play when we want to split our data by an additional field. Let's take our previous search and split the data by which host the error occurred on. adding by host to our search. Splunk creates columns for each of our hosts. Unlike the stats command, only one value can be specified after the by modifier when using the over clause. If two by clauses are used without the over clause, the first field will be used as the over clause. Now that we have multiple items in our legend, if we hover over them, we can see the field values highlighted across the graph. Let's get a count for unsuccessful shopping cart transactions over the last 7 days, per host, and split the data by product. As you can see, the null data skews the results. This is because there are events where a product name is not present in the event, so a null value is used. To remove the nulls, we can add an argument of useNull equals F, or false, to our chart command. While this does remove the null column from our chart, in this case it would be much more efficient to remove all null items before piping to the chart command in the first place. The chart command, by default, is limited to 10 columns. Others can be included with a limit argument, but by default show up as other in your events. The other column can also be removed by using an argument of useOther equals F. The useNull and useOther arguments default to true. So if an argument is not specified, these events will be included in certain arguments. By using an argument as other in your event. Others can be included with a limit argument, but by default show up as other in your events. The other column can also be removed by using an argument of useOther equals F. The useNull and useOther arguments default to true. So if an argument is not specified, these events will be included in search results. Using a limit argument, we can adjust the number of plotted series shown. In this case, the number of products. Or we can use a value of 0 to display all products. The time chart command performs stats aggregations against time. Time is always the x-axis. We can see a timeline of vendor sales by piping the search terms into the time chart command with a function of count. By looking at the data as a line chart, we can see the number of sales over the time of the sales. In this case, 7 days. By rolling over the timeline, we can see the count by specific day. We can also split the data with a by clause to see timelines for each product. Similar to the chart command, any stats function can be applied to the time chart command. Only one value can be specified after the by modifier. The limit, useOther, and useNull options are also available to time chart. The time chart command intelligently clusters data in time intervals dependent on the time range selected. If you roll over the chart, you will see that the data is clustered by 24-hour groups. To change the span of the time of the cluster, you can use an argument of span with the time to group by. Now when we roll over the graph, we can see the data is now in 12-hour groups. Group by. Cluster, you can use an argument of span with the time to group by, the cluster or hour groups. To change the span of the time of the cluster, you can use an argument of span with the time to group by. Now when we roll over the graph, we can see the data is now in 12-hour groups. The trendline command computes moving averages of field values, giving you a clearer understanding of how your data is trending. Let's use trendline to see a trend of our sales over the last 7 days. The trendline command requires 3 arguments. The trend type. You have choices of simple moving average, exponential moving average, and weighted moving average, also known as SMA, EMA, and WMA. The SMA, EMA, and WMA compute the sum of data points over a period of time. The WMA and EMA assign a heavier weighting to more current data points. You need to define a period of time to use for computing the trend. This needs to be an integer between 2 and 10,000. In this case, we're searching over the last 7 days, so a value of 2 will compute a trend. We're to be you need and compute the sum of data points over a period of time. The WMA and EMA assign a heavier weighting to more current data points. You need to define a period of time to use for computing the trend. This needs to be an integer between 2 and 10. Computing the trend. This needs to be an integer between 2 and 10,000. In this case, we're searching over the last 7 days, so a value of 2 will compute a trend over the last 2 days. Lastly, we need to define the field to calculate the trend from. Now we can run the search. We can see data for both the sales and trend and can visualize them in a chart. As you can see, transforming commands are a pretty deep topic. Let's have a quick summary of what we've learned so far. If you want to count the frequency of fields, use the top or rare commands. Use the stats command to calculate statistics between 2 or more fields when you do not need the data to be time-based. Use the chart command when you want to calculate statistics with an arbitrary field as your x-axis that is not time. Using the by modifier, each column represents a distinct value of the field we are splitting by. If you need to calculate statistics with time as the x-axis, use time chart. Time chart also allows you to split data by a field. There are several options for representing data that includes geographic information. Splunk includes commands that let you pull geographic data from your machine data, and visualizations to display the data in an easy-to-understand format. Marker maps plot geographic coordinates as interactive markers on a world map, while choropleth maps use shading to show relative metrics for predefined geographic regions. The IP location command is used to look up and add location information from a third-party database to an event. Data such as city, country, region, latitude, and longitude can the IP location command is used to look up and add location information from a third-party database to an event. Data such as city, country, region, latitude, and longitude can be added to events that include external IP addresses. Here we are searching the index for users that logged into our servers from IPs outside of our internal network. Piping the events into the IP location command. With the src IP field as the argument, we now see location fields created by the IP location command. These include fields that can be used with the geostats command for mapping. Please note, some location information may not be available for particular IP addresses. This is the nature of geolocation and should be taken into consideration when searching your data. If an address is not found in the third-party database, such as an internal IP address, no fields will be added to the event. If you're collecting geographical data, you can use the geostats command to aggregate the data for use on a map. The geostats command uses the same functions as the stats command. If we pipe our vendor sales into the geostats command with required latitude and longitude values and do a count, Splunk returns data clustered by location that we can use on a map. We use a lat field argument for latitude and a long field argument for longitude. The geostats command allows you to split your data using the by argument. Unlike the stats command, the geostats command only accepts one by argument. To control the column count, a global limit argument can be used. As mentioned before, you can look up geographical data to use with geostats using the IP location command. Let's take our search from before and pipe it into the geostats command with a count function. We use the lat and long fields created by the IP location command. These are the default values for the lat field and long. long field command. These are the default values for the lat field and long field arguments. If you have a lookup table with a list of private addresses, you can replace those field names with values from the lookup. We can now see the locations that employees are accessing the servers from. Hey security guy, does this look right to you? A choropleth map is another way to see your data as a geographical visualization. They allow us to use shading to show relative metrics over predefined locations of a map. In order to use choropleth, you'll need a KMZ, or compressed keyhole markup language to use metrics visualization. A choropleth map is another way to see your data as a geographical visualization. They allow us to use shading to show relative metrics over predefined locations of a map. In order to use choropleth, you'll need a KMZ, or compressed keyhole markup language file, that defines region boundaries, or a map. Allow us to use shading to show relative metrics over predefined locations of a map. In order to use choropleth, you'll need a KMZ, or compressed keyhole markup language file, that defines region boundaries. Splunk ships with two KMZ files, GO/US states for the United States. In order to use choropleth, you'll need a KMZ, or compressed keyhole markup language file. That defines region boundaries. Splunk ships with two KMZ files. GO/US states for the United States, and GO countries for the countries of the world. But other KMZ files may be used. To prepare our events for use in a choropleth, we use the geom command. To prepare our events for use in a choropleth, we use the geom command. The geom command adds a field to our events that includes geographical data structures. That match polygons on our map. To see it in action, let's search for vendor sales for our vendors in Europe over the last 7 days. We pipe the results into the geom command, followed by the name of the KMZ file, also known as the feature collection. A feature ID field argument is required. In this example, we're using a field with values that map back to the country name in the feature collection. When we run the search, we can see in the Statistics tab that we have a geom table of polygonal data. When we display this information as a choropleth visualization, the polygons are rendered over the map and colors are assigned to the data points. When your results contain a single value, there are two different types of visualizations you can use to display them. Single value and gauges. Visualizations you can use to display them. Single value and gauges. The single value graph displays a single integer. Formatting allows you to add caption text under the visualization, add color based on numerical ranges, and change format of the numbers, including adding information before or after the value. You can also use a time chart command to add a trend and sparkline to the visualization. We are given a single value for the sum of items sold for the last day, and trend and sparklines comparing the results to the previous days. In this case, due to our search being over the last 7 days, totals for each day were automatically used to derive the trend and sparklines. But formatting allows you to choose the time samples and remove the sparkline. The trellis option allows us to split our visualizations by a selected field or aggregation. In our current search, by a selected field or aggregation. Allows us to split our visualizations by a selected field or aggregation. In our current search, we are getting a sum of all web sales. We append a by clause to tell Splunk to split our results by product name, expand the trellis menu, and select Use Trellis Layout. Now we see individual visualizations for each of our products. While multiple visualizations are displayed, the originating search is only run once. The radial, filler, and marker gauges can be used with single values by selecting them from the visualizations menu. You can set range segments using format options, or you can pipe the events into a gauge command to set ranges using the Splunk search language. The color of the gauge can be changed in the format dropdown. Since more sales are a good thing, we're going to change the color ranges to better suit the data. Once the color range format is set, it stays persistent over the radial, filler, or marker gauges. When your results contain a single value, there are two different. Let's explore some additional formatting options in Splunk, beginning with statistical tables. After running a search using a transforming command, we see a format link in the Statistics tab. We have options to wrap results, show row numbers, change the click selection from cell to row, and add a data overlay. The data overlay can be a heat map of values, or highlight the high and low values in the table. The Summary tab allows us to add totals and percentages to columns. When selecting totals, numerical totals for a column are added up and displayed in a new row at the bottom of the table. The percentage option will compute the percentage for each column and create a new row at the bottom of the table. The chart overlay setting comes in very handy when using trendline. Let's look at a search we ran in a previous segment. This column chart displaying our web sales data uses the time chart command to get a sum of all products sold over the last 7 days, then pipes to the trendline command to see the trend of those sales. We open the Format menu, select Chart Overlay, and have options to either overlay our sales or trend values. Selecting Trend overlays a line graph of trends in our data on top of the column chart displaying sales. The Format menu contains different options depending on the visualization type. This column chart visualization has options for the X and Y axis, Chart Overlay, and Legend. Whereas this single value visualization has format options for color and number format. It has been a pleasure to join you on your journey to learning about Splunk. We suggest you check the documentation and register for additional learning modules from Splunk Education. Thanks for watching. An ID field back to the and supply an optional argument to format it with commas. It's important to all this magic happens in Splunk's user interface. Splitting by. If you need to calculate statistics with time as the x-axis, use time chart. Time chart also allows you to split data by a field. There are several map, and colors are assigned to the data points. When your Thanks for watching.
Hello, welcome to Working with Time. I'm Jessica with Splunk Education. Time is one of the most important components to consider when working with your data. In this module, we will learn how to work with time in searches, including time-based functions and commands, and understand how time zones are represented in your data. To know how to create searches including time, it's important to understand what time means to Splunk. When an event is ingested, its timestamp is stored in the time field. When an event is ingested, its timestamp is stored in the time field. This is used to create the event timeline in the Splunk web user interface. This is used to create the event timeline in the Splunk web user interface. The time field is stored with the event in the index prior to search time. Along with default fields such as host, source, and source type. Timestamps are expressed in Unix or epoch time, and translated to human-readable time during the search operation process. All events are sorted by time, thus, time is the most efficient filter. The underscore time field's timestamp is displayed underneath this time column within each event. That timestamp is adjusted to your local time zone as long as the time zone is set within the account settings. Along with that, every single event will have a specified host, source, and source type, as well as the index that that event is stored in. What we'll see when we run a search above the events is a timeline, which is an overall distribution of the events in relation to the specific time range set for that search. This timeline is interactive. We can zoom in, zoom out to a specific time range within the timeline. We can format it to give it a full-blown X and Y axis, and we can start rearranging our time range depending on how we interact with this timeline. We'll notice that if we click and drag a portion up the timeline, it will be a subset of time, in this case 6 hours. And if we would like to update our time range to zoom into these 6 hours of data, we can select Zoom to Selection. The event list updates when we click and drag over one or more bars within the timeline and displays only the events that occurred within that selected time range, being a filter of the search results. However, the search will not rerun. It is essentially just filtering the events and displaying them as usual in reverse chronological order. If we wanted to cancel this selection, we can select deselect, or Zoom to Selection will allow us to filter filter the results of our previous search for our selected time period, and update to show the results of the new search. In that case, we've now zoomed into the selected time range, running a brand new search. Let's go ahead and switch on over into a demo and run a search here, specifying our security index, source type of Linux Secure, and we are looking for failed logins into the server across the last 24 hours. Now we'll notice here we have a couple small peaks within this time range. Notice that if I hover over the timeline, I can see the time range is set to 1 day, which is correct in terms of what my time range is set to, which is the last 24 hours. And I may be interested in some cases if there's a gap in my timeline or a sudden peak in my timeline, what occurred within that specific time range within my events. So the option for zooming on into that section is just clicking and dragging, and we'll notice that as I continue dragging, I can see the time range expanding. These are 4 hours of time between these specific hours of May 13th, and I can see that I'm filtering to those specific 4 hours, but if I wanted to zoom to selection, I'm rerunning a search, zooming in and looking at the results of that search. And I can see that now, since I'm looking at 4 hours worth of data, this is going to update my timeline for this brand new search. Now, zooming out does not take me back to the previous timeline. It literally zooms out in time. If I wanted to go back to my previous timeline, I would just go back within my browser and possibly, let's say, zoom out, which would further expand this from 1 day to, we'll see here, 1 month. And as we continue expanding and zooming out in time, the time range continues growing. Now we can control the overall time range for our search with a bit more detail using the time range picker. The time range picker has quite a few time range options to choose from. One of those being the preset section with a set of time options to choose from, let's say last 7 days, last 24 hours being the default, previous week, previous month, or we can run a real-time search. The real-time search will return results up to the second they're coming in. Benefit of that is that we see data as it's coming in to Splunk in real time. Downside is that real-time searches are resource intensive. Real-time searches will consume an entire CPU core. They continuously update search results as the events arrive. However, if we're running multiple real-time searches, that could possibly impact the overall performance. One alternative to consider would be to use something like a scheduled report. Now, along with these preset time ranges, we can also see that we have some relative time options where we can specify our earliest time range a few seconds ago, minutes ago, hours, days, weeks, months, quarters, or years. Latest will be up until now or the beginning of, let's say, the current hour. The specific date and time will be displayed right underneath. And there is an entire dedicated section to real time, where we can provide the units for how earliest and latest will be up until now. So what this will do is it will essentially display the data that has come in, let's say 1 hour ago, up until now, as it's flowing into Splunk. Now, along with that, we can also be a little more specific in terms of our dates. If we'd like to search for data that came in, let's say, between last Tuesday and Thursday, we have an option to specify a time range between that, along with the date and time, let's say last Tuesday and Thursday at noon. Those events with those timestamps will be returned. And then lastly, we have the option to specify time unit abbreviations within this advanced section, which will allow us to be even more specific about our time. With these time unit options, we can use them within the earliest and latest time modifiers in our search, or within that advanced section of the time range in options. We can use them within the earliest and latest time modifiers in our search, which unit will be returned. And then lastly, we have the option to specify time unit abbreviations within this advanced section, which will allow us to be even more specific about our time. With these time unit options, we can use them within the earliest and latest time modifiers in our search, or within that advanced section of the time range picker. The syntax is we use plus or minus to look forward or back in time. The specific time unit, and we can round down or snap down to a specific time unit. Using this @ symbol. Let's take a look at a couple examples. If we are interested in running a search, examples, time unit using this @ symbol. Let's take a look at a couple examples. If we are interested in running a search and returning results that have come in across the last 30 minutes, snapping down to the beginning of the hour, in that case, that will, let's say, look back at 9 o'clock if it's, let's say, 9:30, and snap down to the beginning of the hour, which in that case is going to set everything to the right of the hour to 0. We are rounding down to that time unit specified after the @ symbol. Now, along with that, we can use -h at h to round down to the hour. And we can also look back a month ago, rounding to the beginning of the month, last 7 days, or looking for events, let's say from 3 o'clock to 9:45. This is all dependent on what your current time range is set to. All of these searches assume that the current time is exactly 9:45 a.m. on April 1st, 2021. So with these time unit abbreviations, we have the option to specify the current date and time, seconds, minutes, H for hours. The current time is exactly 9:45 a.m. on your current time range is set to. All of these searches assume that the current time is exactly 9:45 a.m. on April 1st, 2021. So with these time unit abbreviations, we have the option to specify the current date and time, seconds, minutes, H for hours, D for days, W for week, days of the week, months, quarters, along with years. And if we take a look here, we'll notice that this advanced section of the time, H for hours, D for days, W for week, days of the week. So with these time unit abbreviations, we have the option to specify the current date and time, seconds, minutes, H for hours, D for days, W for week, days of the week, months, quarters, along with years. And if we take a look here, we'll notice that this advanced section of the time range, take a look, months, quarters, 1st, 2021. So with these time unit abbreviations, we have the option to specify April 1st, 2021. So with these time unit abbreviations, we have the option to specify the current date and time, seconds, minutes, H for hours, D for days, W for week, days of the week. Months, quarters, along with years. And if we take a look here, we'll notice that this advanced section of the time range picker allows us to incorporate these time unit abbreviations. We are looking back 24 hours ago, snapping down to the hour, and we'll notice that if I remove that @ symbol, 24 hours ago from now is going to be 11:04 p.m. and 55 seconds. However, I decided to snap to the beginning of that hour, which will round down to the hour, which will be just 11 p.m. up until now, which is the current time. That's applied and that's updated as the time range for this search. However, with the earliest and latest time modifiers, I can update this to say, let's look back across the last 5 minutes of data. I'm including earliest here equal to -5M, M for minutes, snapping to the beginning of that minute, and latest is now. Now, which time range will take precedence, the time range that I have embedded in my search or the time range in my time range picker? Notice right below here, the time range embedded in my search using the earliest and latest time modifiers is what is used for the time range. That will take precedence over whatever time range is set in that time range. Picker. There are a set of fields that are available in most cases for controlling the time of our searches. These fields all begin with a date _ prefix followed by a specific time unit, whether that's hour, minute, month, second, year. They follow the same format, and these date _ fields are only generated for events where inside the raw, and these date _ followed by these fields in most picker. There are a set of fields that are available in most cases for controlling the time of our searches. These fields all begin with a date _ prefix followed by a specific time unit, whether that's hour, minute, month, second, year. They follow the same format, and these date _ fields are only generated for events where inside the raw event, Splunk is able to extract the timestamp. Now you may be wondering, don't all events that Splunk logs have timestamps assigned to them? Well, every single event will be assigned a value for _time, but not all source events have an actual timestamp value in them. Well, every single event will be assigned a value for _time, but not all source events have an actual timestamp value in them. Let's go ahead and take a look at an example here. Running a search across index equal to web, source type equal to access combined across the last 24 hours. If we take a look at these events, we can see that there are indeed timestamps in the raw event, wrapped here in square brackets. And we can see here that we have an IP address preceding it, right? But there's a timestamp right after that. In a lot of your log files, the first value will be a timestamp. And Splunk's default event processing is that it wants to break events at the timestamp. Whenever it sees another timestamp, it will want to break it into a new event. Now, are the timestamps in this time column and within the event itself always going to be the same? In this example here, we can see that the time is the same. We're looking at 6:38 and 27 seconds PM, and we're seeing the same thing in the timestamp in the raw data. Now, the reason that these are coming up the same right now is because if I make my way up into my account settings and my preferences, what I'll see here is that my time zone is set to the default system time zone. I am using the time zone of default system time zone, so there is no localized offset being applied to my _time field. If I were to change this to my local time zone, what would happen is there would be a differential from GMT, so the timestamp value would be offset from the _time. In that case, if I apply this, rerun this search, and we see differences between what appears in the raw data and in the time column, notice there's a difference there, chances are we've set a local time zone preference. Now let's take a look at a different set of data. We'll change our index to OS, source type to PS. PS is a scripted input. It is a process snapshot Unix command running in the background every 30 seconds. We captured the standard output into events, and we'll notice that we don't have any of those date_time fields in the sidebar. Versus for the previous search, if we take a look at the field sidebar, we have all of these date_prefix fields available. Now, the reason why we don't have any of those fields is taking a look at the actual events themselves. There is no timestamp. Splunk is not able to extract a timestamp from within the event, yet a timestamp is applied for those events. So the question is, where did this timestamp in the time column come from? Notice that the timestamp is the same for each event. Splunk tried to find the timestamp inside the event. It wasn't able to, so it defaulted to its fallback, which is the index time. That is the time that these events were indexed, and that's what gets assigned for _time. There are no date_ fields present here, and that's because Splunk was not able to extract them from the event itself. When they're present, we can use them to solve specific use cases by using them in our searches. If we take a look at this scenario here, let's say a new campaign aimed at early morning sales is ongoing, and we want to display early morning retail sales for 2 to 5 a.m. for the previous 2 days. All right, so let's go ahead and run a new search here, and we are going to look at the time range for the previous 2 days across the index of sales, source type of vendor sales. Earliest is looking back 2 days ago to the beginning of the day. Latest is snapping down to the beginning of the current day. Looking back 2 days ago will be on May 12th. To today, May 14th, snapping down to the beginning of the day, which is midnight. And we are interested in displaying early morning retail sales for 2 to 5 a.m. for these previous 2 days. Notice in the field sidebar, we have the date_hour fields. Let's use those in our search and specify date_hour greater than or equal to 2 and date_hour less than 5, which will work with the midnight time looking forward 2 hours. So we're looking for a value greater than 2 and less than 5 to look at the retail sales between 2 to 5 a.m. for the previous 2 days. If we run this search, what we're going to do from here is place our data in a table. And what we will use is this command called the bin command, where we are going to bin up the time values, each being 1 hour apart. And what we'll then do is place this information on a table looking at the total revenue, naming this hourly sales by _time. And what we should see on this table is early morning retail sales from 2 to 5 a.m. Now, if we reformat this _time value to make it a little more readable, we can use a function of the eval command, create a new field called hour, and the function here is called the strf time function. The first argument will be the field that contains the time values, in this case _time. Second argument will be the date time format variables in the format that we want to place them. So in this case here, we will be using %B, %D, %I, %P, which is going to display this in month, day of the month, hour, and whether it is AM or PM. We can find these date time format variables and their descriptions in the Splunk documentation on the strf time function. Let's go ahead and run this search and take a look at this newly created field and its values in this column. And we notice something that isn't as we expect. We expect this to be 2 to 5 a.m., not 7 to 9 p.m. So why are we seeing a difference in the actual times? Well, remember, we changed our time zone earlier. So if we make our way back up into the preferences, switch back from Pacific time to the default system time zone, apply and rerun the search, we will notice that those time zones are updated and the time values are correct in that hour column. And we can then just place hour and hourly sales as the two columns that we want in our table. The date underscore prefix fields do not account for time zone. Now, in that last search, we just used the bin command. The bin command is used to help us bucket up our events. We can put numerical values into discrete. Sets or bins, and the bin command has a span option that is set to an integer or a timescale that allows us to set the size for each bin. In this case here, we can adjust the bins if they're being organized based on time using the span option, specifying a time interval where these are each going to be 1 hour apart. And here we have an example of the different timescale values that are available. We can specify seconds, minutes, hours, days, months, subseconds. And one example here is that we would like to list the number of times an action was seen on the SIEM Cubicle beta server over the last 10 minutes and group actions into 2-minute chunks. In this case, we're searching across our game's index source type of SIMQ beta, looking for events that contain an action field across the last 10 minutes. We are going to group together the underscore time values, each of those time bins being 2 minutes apart, and then placing that information on a table, getting a count of events and listing out the actions by time. Now, along with binning up underscore time, let's take a look at one more example using the bin command, this time going back into our online transactions and displaying the total revenue per product across the last 24 hours. We will pipe to the stats command, sum the price, name this revenue per product, and run this search. I would like to bin my revenue by piping to the bin command, passing in revenue as the field and running the search. And what I'll notice here is that these different values are grouped together and these bins are each 10,000 values in terms of what the span is set as. If I wanted to adjust the span, I can specify span equal to, let's say, 5,000. So I'm lowering the span count, each of these bins now being 5,000 values in terms of the overall range. Now, if we wanted to look at the list of products by revenue and see all of the products that fell within each revenue range, we could go ahead and pipe over to the stats command, list function, product name, by total sales, and display this information in the table. Now, total sales is not a field that we're working with, so we want to make sure that we're specifying the correct field. In this case, it is revenue. And so what we're looking at here is all of the products that fell within the $0 to $5,000 range, $10,000 to $15,000 range, $15,000 to $20,000 range, $25,000 to $30,000, and $5,000 to $10,000 range. If we wanted to, let's say, format these numeric values to display monetary values, we can update revenue and concatenate a $sign to the front of these values here, that then being updated.
Bro, I'm not gonna lie, I'm not gonna be able to do any of that.
You can define how time is formatted in the search results by using the time functions of the eval command. The eval command is a very powerful command that allows us to write the results of an expression to a new or pre-existing field. We can chain multiple eval expressions together by comma separating them, and the eval command supports its own set of functions. Some of those functions being date and time functions that allow us to generate time values and manipulate time. If we take a look at the now function, the now function returns the time that a search was started, the time function returns the time that an event was processed by the eval command. We can set those functions as values of the fields that we're creating with the eval command that will store those particular timestamps. The relative time function is a function that takes in two arguments, the first argument being the actual time value, that time value will be represented in epoch time, and the second argument being a specific time specifier using the time unit abbreviations. S for seconds, M for minutes, H for hours, D for days, W for weeks, MON for months, and Y for year. If we take a look at this example here, we're creating a new field called yesterday, setting it equal to the relative time function. First argument will be the time generated by the now function. Second argument will be based on the time right now, we are going to look back 1 day ago, snapping to the beginning of the current hour. What this is going to result in is a time value, which is represented in epoch time, stored as a value for that field of yesterday. Now, for working with the strf time and strp time functions of the eval command, These have date time unit abbreviations, each one representing a different unit of time. If we take a look at an example here and make our way over into the Splunk documentation, date and time format variables page, we can see some information about what each one of these mean when we're using them in these functions. And what we'll notice here is if we're interested in specifying AM or PM, percent lowercase p, if we're interested in specifying the full weekday, percent uppercase A, abbreviated weekday, specifying months, years. So here we have a few examples where if we place symbols, those symbols will actually be displayed in our result. This is helpful for formatting our time values, where in this example here, the epoch time generated by this relative time function, which is stored in the yesterday field, is going to be formatted into a more readable format by this strf time function, where the time value that's stored in yesterday will be passed in as the first argument, second argument being in the format of year, month, day, hour, and minute. So jumping on over into an example here, let's go ahead and run a new search using this strip time function where we are formatting the time values. If we take a look at our retail sales data, index equal to sales, source type equal to vendor sales, and we display our data in a time chart where we're interested in looking at the hourly sales, and we would like these time buckets to each be 1 hour apart. We can see the underscore time column contains these time values displayed in the month, day, year, hour, minute format, but I would like to format this into something a little more readable using the strip time function. So what I will do is pipe to the eval command, update underscore time. As an alternative, I could create a new field just to compare it to underscore time. So we can create a new field named, let's say, formatted time, and set that equal to the strip time function with underscore time as the first argument. And then we're going to use these date time format variables, percent lowercase b being the abbreviated month, percent lowercase d being the day of the month, percent uppercase I being the hour, and percent lowercase p being AM or PM. We run this search, and we can see that formatted time being displayed here in this column. Now, difference between the strip time and the strp time function is that this function here is going to take a time represented by a string to a Unix timestamp. So we're essentially going from a formatted value to epoch time. First argument will be the field that contains those formatted time values. Second argument using the date time format variables in the order that the format is specified in for that first argument. This will result in a newly created field with those epoch time values. Let's take a look at two commands that can be used to work with time, beginning with the time chart command. The time chart command performs statistical aggregations against time. As we continue discussing time, the time chart command is a transforming command that allows us to plot our data out over time, with time always being in the leftmost column of our table and on the x-axis of our visualization. The time chart command supports the same family of functions as the stats and chart command, and has a built-in span option that allows us to control the overall time spans of our time buckets. If we take a look at an example of a basic search using the time chart command, we can see here how many usage violations have occurred during the last 7 days. Now, if we take a look at this here in a search and we make our way over into the network index source type of Cisco WSA Squid, we take a look at the field sidebar and we have a usage field with a value of violation. At the very top, we are going to filter on with usage equal to violation, and then take a look at this information within a table and visualization using the time chart command. I will use the count function to display the count of usage violations that have occurred over the last 7 days, looking at the count value per day. Time charts are best visualized as a line or area chart, so we can get some information here about how many usage violations we had each day. We can see the peak being on May 12th. Now, this here is a single series time series, 2 columns in the table with time being in the leftmost column, and a single color or line in the visualization with time being on the x-axis. Now, if we adjust our search to figure out what the overall usage trend was for, let's say, the last 24 hours, we will update our time range to the last 24 hours. And this time we are going to pipe to the time chart command, get a count of events by vendor action, so that we look at the overall usage trend for the last 24 hours here. Now, we want to make sure that we are specifying the correct index, so security source type of Linux Secure, because the Cisco WSA Squid data does not have a vendor action field. Now, once we update that, we are going to see that we have a null column because there are a few events that have a null value in the vendor action field. So we can filter on this and look for only those events that have a vendor action field. That removes the null column from our table. And now we're looking at multiple columns in the table, multiple series in the visualization, with time still being on the x-axis. Now, if we wanted to control our time spans here, we can see that these are each 30 minutes apart. The time buckets that Splunk creates and the intervals between each one of these time buckets is dependent on what your time range is set to. When the time range is set to the last 24 hours, the default span is 30 minutes. When the time range is set to the last hour, the default span is 1 minute. And if the time range is set to the last 7 days, those time buckets are each going to be 1 day apart. Now, we can adjust the span just like we used with the bin command. We have the span option built into the time chart command that allows us to specify a span with the time units. In this case, let's specify a span of 15 minutes. These are each 15 minutes apart, and we can see the visualization being updated as well. Now, running a brand new search across the web index, source type of access combined, let's take a look at a total price per product. And we will see here that the time chart command displays in this table here an other column and then 10 products. So we're looking at 10 products, and the intersection of the cells is the overall total sales for each of these 30-minute intervals. If we wanted to see the total sales for, let's say, the top 5 products, the time chart command has a limit option that allows us to control the number of values for this split by field that are displayed. By default, the time chart command, like the chart command, displays the top 10 values. We can control that using the limit option of 5 to display what the total web sales were for our top products during the last 24 hours. Everything else is grouped together in this other column, and we can go ahead and take a look at this information within a visualization as well. Now, in addition to the time chart command, the time wrap command can be used to display the output of the time chart command so that each time period is a separate series. The time wrap command is typically going to follow a time chart command. It is going to allow us to compare specific time periods to each other. For example, comparing, let's say, the number of password failures over the last 2 weeks, looking at each week by week. It is followed by either an integer or a time scale. And if we take a look at an example, integer or a time scale. And if we take a look at an example, in this scenario here, we'd like to compare the number of password failures over the last week to password failures over the previous week. So in this case, if we run a brand new search, we are going to specify a new index of security, source type of Linux secure. We are looking for failed passwords across the last 2 weeks. Now from here, we will pipe to the time chart command and display the count as failures. And if we take a look at the total failures across the last last 2 weeks, this will be displayed as a single line in the visualization from Friday, April 30th to the current date. Now, I'd like to compare the total failures across the last 2 weeks, week by week. In that case, we will pipe to the time wrap command, specify this time unit abbreviation of 1 week, and all of a sudden, we see 2 lines in our visualization. They are automatically labeled failures 1 week before, failures latest week. And if we take a look at the table here, we can see 2 columns being displayed as well. Now, if we wanted to format _time, we can use the strict time function that we talked about earlier. Let's say we want to rename _time as day, and then update the values stored in day here to display just the day of the week. So in this case here, we now see day of the week on the x-axis. In our table here, we are renaming _time as day and then formatting it using the strict time function of the eval command. If we were interested in expanding the time range to, let's say, the last 19 days, we will now see 3 columns in addition to the time column. And within the visualization here, we will see 3 lines. If you've ever worked with time-based data for multiple geographic locations, you know time zones can be tricky. In this segment, we'll learn how time zones are represented in your data and use the strict time function to correct time zones in search results. One thing to keep in mind is to always check your data to verify that it is returning the expected results. What we see here as the results of this search that contains a bin command as well as the date_hour fields, displaying the early morning retail sales for 2 to 5 a.m. across the previous 2 days. We can see here that we are displaying 9 to 11 p.m., whereas we're expecting 2 to 5 a.m. Now, one thing to keep in mind is your time zone. Remember that the date_time fields do not take into account time zone of Splunk Web. All right, so in this case, we want to make sure that we are setting our time zone to the default system time, or as an alternative, using the strict time function to organize our data and normalize it. The strict time function, we can pass in the _time field as its first argument. Second argument will be the specific hour. And the difference here between the date_hour and my hour is taking into account the time zone that is set. Using the eval command with the strict time function uses the timestamp that is aligned with your time zone to retrieve the hour from the event and return a human readable format. The date_hour field will not adjust the hour based on your Splunk Web time zone. So rearranging the search from earlier with the strict time function as opposed to using the date_hour fields, if you'd like to use your set time zone, we can create a new field called myHour equal to the strict time function where we are formatting _time to be displayed with that preserved time zone. It has been a pleasure joining you to learn about working with time in Splunk. We suggest you check out the documentation and register for additional learning modules from Splunk Education. Thanks for watching.
But there's no way I'm passing this quiz. Oh, now they have correct things in it?
For me, why somebody would want to learn Splunk, I don't want to say I'm betting my whole career on learning Splunk and making, the next few years of my career very Splunk heavy, but I'm betting my whole career on Splunk. I'm really, going very heavily into a job role that really only leverages Splunk architects or Splunk admins. For me, why somebody would want to learn Splunk, all right, welcome everyone to a career in IT. So be sure to check out the Green to Green Cybersecurity Bootcamp and join us on our Discord server as well. So and then the course moving. Towards the mind map on the left here, you can kind of branch out and draw the arrows to wherever you'd like after you kind of complete the cybersecurity bootcamp. You can also get certified in cybersecurity. ISC Squared has put out a new certification that is 100% free. They have pledged to cloud providers are Microsoft Azure, Amazon Web Services. One of them has gone Udemy from Jason Dion or David Tube, but it's the best bang for your buck certification you can have on your resume. But it's going to racking up their certification prices. It's going to ring you about $385 to go test. If you want to be further on after your network career, maybe you go on to follow David Bombal. He has a lot of great free material and learning on Udemy Certified Network Administrator certification, going the route of you want to be a network engineer route. Another great resource is SANS Work Study Program. This is going to bring you $2,500, but it's going to hold the most weight that you can have on your resume for holding a certification in the field of cybersecurity. SANS courses on their own are getting up there to be $9,500 for one course, which includes your exam voucher. But if you do the work study program, you go in person, you help out the instructor, setting up and tearing down the course, setting up the labs, answering students' questions. And if you do all of that, they'll offer for you to take the course. You can kind of choose and get on a wait list based on what area they're coming to, or do one on live with live instructor-led training for the low price of $2,500. That's going to be the steepest price point offering here, but it's the best bang for your buck certification you can have on your resume. SANS training really is top of the line when it comes to the cybersecurity industry, and that certification is going to go the furthest on your resume for employers and salary boosts. Blue Team Level 1, also a great company that's out there. I don't know why they charge so much for their memberships, but around $600 you can go through their Blue Team Level 1 certification and get a digital badge through them. They also have like membership pricing on their website, so I would encourage you to check them out for more information, but their certification is starting to hold more and more weight with employers for people trying to get a SOC job or a junior cybersecurity analyst, tier 1, tier 2 position. And then Rangeforce. Rangeforce is a hands-on tool that you can use for training, and they have a bunch of different modules in there for education, and you have access to their entire platform. And I believe they still offer the $500 for students discount. They also have a free community edition. That you can register for and get a feel for the platform. Tools on a whole lot about red team operations, so I'm really just going to boot you to THM Security, Try Hack Me, Black Hills Information Security again with John Strand, and John check engine from their formal training and the certification printout at the end. Tool is a great resume to have. 99 is tools section. These are tools that if I were trying to transition into the field, what I would pair with the courses that you're going to in green for making your resume and knowledge overall so much stronger. So starting with Wireshark. Wireshark is a network protocol analyzer, and it's 100% free to go and download on Udemy, very affordable, $12.99, or if you follow them on LinkedIn and their socials, they often do a lot of promos for free courses. To David, he's over here for the anything network related with a great YouTube channel. Chris Greer, if you follow them on LinkedIn and their socials. Another great tool is Cribble. Cribble and Splunk are pretty similar, but Cribble's training is 100% free. They also have a great Slack channel to become involved with, and if you go over to their website, you can get both the user certification and the admin certification from their formal training and the certification printout at the end, both 100% free. So if you're looking to go towards blue team operations or data ingestion and where to save money when it comes to everyone onboarding data into a SIEM or a similar solution, Cribble is about to be available on LinkedIn and Udemy, and we have all the training on Splunkable available to you for power user, admin, and in development architect. Now, if you go with Splunkable's training on Udemy and their Slack channel, they often do that in mind. And then, unfortunately, if you want to be a Splunk architect, you're going to have to still pay for formal education. This box here is just outlining all of the SIMs that are out there. So Splunk is one of them, paid for. Definitely. Moving away from the SIMs, if you're going to take an EDR route, well, you can definitely learn Microsoft Defender for Endpoints, which is 100% free, available on Microsoft's website. They have all the documentation in there, and you're off to the races learning it. You can also reach out to us for our Udemy course for our CrowdStrike Certified Falcon Administrator, and to sit for that exam, you do have to pay CrowdStrike, and through Pearson View, register for it, and it's actually $250 to sit for the exam. But with this, you get a free retest. So you pretty much get 2 exams for the price of 1. In the event that you fail it the first time, it's a free retake. The open source tools that you want to be having on your maliciousness is any run sandbox. You can pay for a membership to sit for the exam. Get 2 exams for the price of 1. In the event that you fail it the first time, it's a free retake. And the course for us, if you hit us up on Discord, happy to hook you up for the Falcon course for free. Otherwise, wait till it's on sale at $9.99 or $14.99 on Udemy. Other free tools that are great resources, AnyRun Sandbox, you can pay for a membership to have your sandbox to do your malware analysis. Virus Total for putting in hashes or $14.99. Other free tools that are great resources: AnyRun Sandbox, you can pay for a membership to have your sandbox to do your malware analysis. Virus Total for putting in hashes and uploading files to see how they rank out for maliciousness. Shodan.io, checking URLs and checking to see what ports and services are open on boxes there, completely free open source tools that you want to be having on your resume. Velociraptor, this one is emerging, completely free. Mike Cohen over there on the Velociraptor team are doing amazing things over there in the digital forensics and incident response realm. So Velociraptor is becoming a leading DFIR tool, 100% free to use. I would definitely recommend you join their Discord server if you're not on it already, as Mike Cohen himself, the creator of VR, is extremely active in there and has answered all of my questions that I've ever had within like a 4-hour turnaround. He lives in Velociraptor and how to use it, how to install it, download, get it up and running on Ubuntu. There's videos and instructions on YouTube and on their website for how to use it as to increase your transition into the field. Lastly, moving into the nice skills to have, you should definitely have a strong familiarity with at least the basics of Python. Go take Jose's course on Udemy for $12.99 and do at least the first half of it before it becomes more complex, and figure out what a loop is, what variables are, how to use Python to take advantage of automation and basic scripts that you can perform. It's really going to go a long way. You can also check out Michael Bentley's book on Amazon for $2.99 on Kindle, and Google also has there, and a great website to use that's free as well for learning your PowerShell skills is called Under the Wire, and I would definitely recommend checking that out after you go through these two to kind of put your skills to the test. But PowerShell, obviously it's a great skill to have. A lot of EDR tools are leveraging it. If you're going to be on a SOC or a cybersecurity analyst position, you're going to need to know what malicious PowerShell looks like, what normal PowerShell looks like, be familiar with the commandlets that are in there, and how people and threat actors are using it as a living off the land tool available to them to use maliciously. So definitely have a strong understanding of PowerShell, going to go a long way. Regular expressions, take the Splunkable regex course, put it out for $13 on Udemy. You're going to have to understand regular expressions. All computers pretty much communicate in some form or another with regex, to include Cribble, Splunk Up, the Academy, available on YouTube, 100% free. Linux is boot process working, what is the registry, what is Active Directory, how does all of that work. Definitely you can check out with the Windows. You can spin up and play with Kali on a Raspberry Pi. Security Now, What the Shell, Cyber Work, Darknet Diaries, podcast, the articles that are being written, how you're staying up, having your morning coffee, my 7 pay, Splunk, figuring out questions, cybersecurity role in defensive operations, Red Team for the offensive operations side.
What is up, guys? Welcome back to the channel. If you're new here, my name is Day and I'm a security analyst and college student, and on this channel I'll talk about cybersecurity. Certified User is pretty much I guess first or second level in how do you study for this exam. I use 3 main resources for this exam. Splunk has a free Splunk course which is pretty sufficient for the exam. I did a review of the course. It's called the Splunk Fundamentals, Splunk 7.x Fundamentals. You can also check out the blog on that. I'll leave a link to that in what you need for the exam. And this course covers everything that you should expect for the exam. I recommend going through the course twice. And you know, first time I went through the course, I went through everything, took notes, did Splunk pretty easily, Splunk Lab, and configure Splunk. But it's really easy. You can easily install Splunk on a Ubuntu server and use them to work in the labs that you will be provided in the Splunk course. They also recommend not doing the labs in the production environment. So if you have Splunk, the flashcards and like some questions that I can expect on the exam. So the first one was really similar to what you could expect in the exam, and just really help you solidify. And it's also it was also a really good flashcard in the to kind of test myself, like what I could put in the description on Udemy. I'll leave a link in the description, like I said before. And just bear in mind that this practice exam has a lot of typos, but I don't think it's anything that, you know, would definitely go home. It was pretty easy to get that done, and you know, they give you your score report after the exam. So yeah, we'll set up a Splunk server.
Hello, welcome to Statistical Processing. My name is Jeff and I'm with Splunk Education. In this module, we'll learn about commands and functions that can help you transform, manipulate, and format your data. Before we get started though, what exactly is a data series? A data series is a sequence of related data points that are plotted in a visualization. In this module, we'll cover three types of data series: single series, multi-series, and time series. Single series data is a sequence of related data points that compares values of a single data category. Multi-series data is a sequence of related data points that compares values of two or more data categories. And time series data is a sequence of related data points that compares values over time, which can be either single or multi-series. Transforming commands can be used in searches to organize your results into a statistical table containing a data series that can be visualized. Transforming commands can be used in searches to organize your results into a statistical table containing a data series that can be visualized. In this module, we'll learn how some commonly used transforming commands are used and how to structure your searches to generate the results you need for the visualizations you want. The chart command is used to take results and return them formatted into a table. Here, we can see an example of the chart command, which will return results in a table format that can be displayed as a visualization. The pipe chart section calls the command. It is then followed by the particular statistical function we are interested in using. For example, count or sum. WC field in this example would be a field that contains numeric values. We can then specify the x-axis of our visualization and also the first column in our resulting table with the over clause, followed by the field we wish to split our rows by. Splits of our columns, resulting in multiple multi-series data series is accomplished by using the by clause. We also have the option to control our results further with the span, limit, use other, and use null arguments. Splitting our results based on the values in a set of fields is accomplished with the over and by clauses. We can create a single series split with the over clause, and a multi-series split by adding a by clause. Unlike the stats command, the chart command can only be split over 2 fields or dimensions. A chart command with 2 arguments after the by clause is equivalent to using an over and by clause. These are functionally identical. Here we can see that our initial search produced a number of results. We can then choose to count these results with the chart count section of the search. We can then choose to split that count based on how many events contain a given value in a particular field. In this case, let's split our data by the vendor country field. This result can either be displayed as a table on the Statistics tab or in a graphical representation on the Visualization tab. Let's now show an example of a multi-series split, one that incorporates both the over and the by clauses. In this example, we can see that we have kept our x-axis and the first column in our chart as the vendor country field. However, let's now add an additional split using the by clause. With the by clause, we can further split our count by the values found in the product name field. This results in a split of our initial count into separate columns in our statistical table. This is also reflected in our visualization as well. We can see here in the resulting visualization that we are keeping vendor country as our x-axis, but now the counts for Canada and the United States are further split by the count of each product. The values for our second split are represented by individually colored columns, and a legend for these values can be seen on the right of the visualization table by default. By default, Splunk will display individual columns for the top 10 values found in the field you use to execute your multi-series split. In this example, this would be the product name field. By adding the argument of limit, you can override that top 10 to whatever whole value you find appropriate. In the example shown, we can see that by adding limit equals 5 to our search string, it's resulted in only having the top 5 values for product name appear as their own individual column. Any values less frequent than the top 5 get aggregated into the other column. Please note that the limit argument sets a limit across the entire data set. It does not give you the top 5 in Canada and then a separate top 5 in the United States, for example. If you want to remove any limit on the number of columns shown, use limit equals 0. Splunk will then give every possible value for your multi-series split field its own column. If the column split has too many values to display in the visualization's legend, the list will include a down arrow to scroll through the values. You can further control the columns shown with the useOther and useNull arguments. The useOther argument will completely remove the other column from your results. Please note that this is only a visual change. This does not recalculate the original results that were generated by your base search. The useNull argument will remove the null column if one exists. The null column will contain the statistical valuation of any events that did not actually contain the field that the multi-series split was based on. In this example, a null column would have been present if any of the events in the initial search returned did not contain a value for the product name field. Here are some additional examples of the chart command. We can see here that our count of events returned by our base search has been subjected to a single series split. We have split that count by the values found in the vendor action field. Here, we see a multi-series split. We have first counted our events by vendor action, and then have further refined our table to split those actions by the different users who took them. Note that in this example, we are not using the over and the by clause, but simply a single instance of the by clause itself. The last report was skewed by surplus categories. By using the useOther equals F argument, we have been able to remove these categories from our report. The span argument allows for arbitrary grouping of values on the x-axis, as long as the x-axis is numeric. This can group events into buckets. Splunk shifts overlap values to the higher grouping. For example, a status code of 400 would have been bucketed in the 400 to 500 range, as opposed to the 300 to 400. In this example, the IT manager wants to see the volume of web activity over the last 24 hours by ranges of status codes. Without the span argument in place, each possible HTTP status code would have been given its own space on the x-axis, possibly resulting in an overly busy chart. The time chart command performs stats aggregations against time. Time is always the x-axis. Aggregations against the time chart command performs stats aggregations against time. Time is always the x-axis. With time chart, we can perform statistical aggregations against time and return a time series chart or table. The function we choose will determine what populates the y-axis of our chart. The x-axis will always be split by time. As you can see, the syntax for time chart command is very similar to chart. Functions and arguments used with stats and chart can also be used with time chart. Like with the chart command, we can choose to split our results table. A key difference between chart and time chart, however, is split used with time chart. Like with the chart command, we can choose to split our results table. A key difference between chart and time chart, however, is that time chart only supports a single additional split. This This is because our x-axis is automatically segmented or bucketed based on time when using the time chart command. We can further control time chart behavior by using the span and limit options. In this example, we've been asked how many events have been logged onto the Cisco Web Security Appliance in the last 7 days. We could simply count the number of events with the chart count command. However, this doesn't show us how that count is split over the last 7 days. For that, we should use the time chart command. We can see here that our leftmost column becomes split by time, and our rightmost columns are an aggregated count within each time bucket. This can be best represented as a line chart visualization. But you are free to use other visualization types if you choose. In this follow-up example, the security team wants to see the previous report but split by the different types of usage. In this case, the values in the field usage become the different series shown on the time chart. The functional equivalent search using chart would be pipe chart count by time, usage. But time chart automatically applies a bucket command to set the time span to a preset sampling interval. Remember, you can only split by one field with time chart. When using the time chart command, Splunk will automatically decide what the appropriate buckets for the values of the time field will be. It does this based on the time range of your search. For example, using the time chart command for a search over the last 24 hours, will make Splunk aggregate the results into 30-minute buckets. A 60-minute search will aggregate results into 1-minute buckets. We can see this reflected in the stats table output by the search in this slide. Each row represents a chunk or bucket of aggregated data. It's possible, even common, that you may not find the time period Splunk uses in this process appropriate. If that's the case, you can override Splunk's bucketing choice by using the span argument. By putting span equals some period of time, you can force Splunk to group buckets based on the time range that works best for you. In this example, we can see that putting an argument of span equals 15M forces Splunk to group data into 15-minute buckets. We can also use the limit argument with time chart in order to control the number of values returned to us for our multi-series split. In this slide, we've been asked, what was the top total web sales for the top 5 products during the last 24 hours? From the search syntax, we can see that we have chosen to aggregate our data into 1-hour buckets with the span equals 1H argument. Our statistical function in this case is sum, and the field we are getting for the sum is price. This means that we are getting a sum of all the values in the price field. We are then splitting our data by the values found in the product name field. Without the limit argument, we would have had the top 10 products returned to us, with 11 lines on our chart, 10 for our products, and 1 additional series for other. By adding limit equals 5, however, we are returning only the top 5 values for product name, along with, of course, other. The time chart and chart commands both take advantage of the same statistical functions. You can equally use count, sum, average, just to name a few, in either command. All commands supported by chart, time chart, and stats can be found in the search manual online in our documentation. In this slide's example, we can see that we're asked, what was the total web sales for our top products during the last 24 hours? Let's show a quick example of the different ways that time chart treats time compared to chart. We're looking at access combined data. Let's see what happens when we split our data using the chart command, but with time as our primary series. Here, we can see we're running a multi-series split with time as our principal split value. Notice the bucketing in the left. There is none. Every time we see a different value in the host field, Splunk considers that a separate series. We can see that the time has no aggregation whatsoever. Anytime there's a host, we get a new row. Let's contrast this with how time chart aggregates data into buckets. Here, we can see how the time chart command has allowed us to aggregate values in the host field based on time, as opposed to the chart command, which gave each host value its own time bucket. When running a multi-series time chart, we have an option in how we want our data to be displayed. Given multiple values in our multi-series split, our time chart can sometimes appear more cluttered than is useful to us. Because of this, we have the option to toggle a feature called multi-series mode. This mode defaults to no, which gets us a time chart as we can see here. If we click on the Format button, however, we have the option to turn multi-series mode to yes. This will separate out our different values into their own lanes on our chart. They share the same x-axis, but at this point they all have their own individual y-axis, almost like their own swim lanes. Toggling this mode to yes can be useful in clearing up order of activity. They all have lanes to yes. That button see here, we have the option to turn multi-series mode to yes. This will separate out our different values into their own lanes on our chart. They share the same x-axis, but at this point they all have their own individual y-axis, almost like their own swim lanes. Toggling this mode to yes can be useful in clearing up order of activity in your data. Note that with multi-series mode, although the different values now have their own y-axis, each one is still uniform in its ceiling and floor. The top command finds the most common values for given fields in a result set. Let's take a look at the syntax. The command starts with pipe top, followed by a list of fields we want to find the most common values for. We can also group results together based on shared field with the by clause. The top command will return a table with the top 10 most common. The top command will return a table with the top 10 most common results by default, but this can be overridden with the limit argument. The optional arguments that can be used with the top command are count field, limit, and show perk. In this scenario, we are asked to determine which IP addresses generated the most attacks in the last 60 minutes. Without any additional arguments, we can see that this search command returns a table which lists the top 10 most common IP addresses returned in our base search. We can see that a percentage is also included. This is because show perk will default to true. Here, we can see the limit argument being used. By adding the argument limit equals 5 to our top command, we limit the returned results for the SRC IP field to just the top 5 most common. This search asks us to display the top 5 IPs that generated the most attacks during the last hour. Another important aspect of the top command is the ability to find top values for specific combinations of fields by adding more than one field to our field list. Here, we can see that our table is showing results for the top 10 most common values in the CS username field. Let's add another field to this list. We can now see a new column. In our previous search, all values for the CS username field were unique. In this search, however, all combinations of CS username and webcat code are unique. The top command will return both a count and a percentage field by default. You can choose to toggle the percentage field, however, with the Boolean argument showPerk. Setting showPerk to false, F, or 0 will prevent the percentage column from being displayed in the resulting table. Count field is another argument that can be added to the top command. In this case, the count field argument allows us to rename the count column from the default of count to whatever string we choose. In this example, we can see that the count column has been renamed total viewed. We can also choose to group our results based on the values in a field. We do this with the by clause. Here, we can see that we are displaying the top 5 users for each web category. Here instead, we're displaying the top 5 web categories browsed by each user. The top command can also be run from the UI. By clicking on a given field in your fields list, you can choose to display the top values by simply clicking on the option shown. As you can see, this actually adds the top command to your previous search string. Note that when you use this method, the limit argument is set by default to 20. You can override this if you want. The rare command has the same options as the top command, but it returns the least common values of a result set. Essentially, the rare command is the opposite of the top command. In this example, we are looking for the product that had the least number of sales by Buttercup Games vendors in a given time period. Note that the same arguments and options available in the top command are also available with rare. To produce statistics from our search results, we can use the stats command. The stats command uses various functions to calculate statistics on search results. Your output in this case will be a table. You can also choose to group your results with a by clause. Unlike chart and time chart, stats allows for continuous splits of your data. You can group more than two fields together with the by clause here. The WC in WC field means that the stats command supports wildcarded fields. Like chart and time chart, stats support statistical functions. But unlike chart and time chart, stats can support multiple fields. In this example, we are asked to count the invalid or failed login attempts during a given time period. Note that we can rename the resulting count column with an as clause. If we do not choose to rename a field with the as clause, they'll be named according to the search syntax. In this example, we can see both a count of events that contain a value in the vendor action field, as well as the overall total of events returned in our base search. This slide further demonstrates how more than one statistical function can be invoked with the stats command. We can do this by separating the functions with commas. We can also see here how the as clause allows us to rename fields in line in our search. In this example, we're counting the total number of events that contain a value in the vendor action field and renaming that result as action events. We're further counting up the total number of events returned by our base search and calling this total events. In the event that we use multiple functions, it's a very good idea to make sure that we rename our results in order to eliminate confusion. As with chart and time chart, the by clause allows us to split our resulting table for stats based on the values in a given field or fields. The order in which the fields are listed has a big impact on the results. Your data will first be grouped by the first field given, then grouped by the second field given, and so on. Here's an example. In this table, we've first grouped our returned results by the values found in the user field, and then by the values found in the tag field within each user. Let's see what happens when we switch the tag and user values in the search. In this table, we can see our returned results are first grouped by values found in tag, and then grouped by values found in user. In the previous section, we used the count function to count the number of events that matched specified search criteria. Let's take a look at some of the other functions that are commonly used with the stats command. We've used two of the aggregate functions, count and sum, in our previous examples with chart and time chart. But there are many different functions that can be used with these commands. Broadly, these functions fall into one of four categories. They either allow us to aggregate values, sort on a dependent order of values, return multiple values from within a given field, or return values based on time. This video does not contain an exhaustive list of the possible functions to accomplish these tasks. Here's a small sample of some of the functions that can be used with the stats command. DC, or distinct count, for example, provides a count of the unique values for a given field in the results set. Here we can see the question was asked, how many unique websites have employees visited in the last 4 hours? Using distinct count, we can get the unique values found within a given field. Let's give an example of the sum function. The sum function calculates the sum of values within a given field, as long as the values are numeric. In this example, we're being asked, how much bandwidth did employees consume at each website during the past week? Let's first set our time range to the last 7 days. We can then use the sum function to begin calculating our bandwidth. Stats, sum of the values found in the SC bytes field. We'll then split this by the values found in the S hostname field. Here we can see the different websites visited on the left and a sum of the values in the SC bytes field over the last 7 days on the right. Let's make our results a bit cleaner for our end user by renaming some of these values. We can rename sum SC bytes as bandwidth to make it more obvious what we're measuring, and then we can sort on the bandwidth field from highest to lowest. Using a minus sign in front of the field you wish to sort, tell Splunk that you wish to sort in descending order, i.e. from highest to lowest. We can combine multiple functions within our stats command, as well as multiple commands within a search. Here's an example where we are asked to report the number of retail units sold and sales revenue for each product during the previous week. Let's first count the number of events that have a value in the price field. We'll call this field units sold. Within the same stats command, we should also get a sum of all the values in the price field, and rename this result total sales. Let's now split our results by the values found in the product name field, thereby giving us the number of units and the total amount of money made per product. Once this is done, we can sort our returned rows based on the values found in the total sales field. Again, the minus sign lets Splunk know that we wish to have this sort done in descending order. 3 more common functions that are used with the stats command are min, max, and average. Minimum will give you the lowest value in a given field, maximum will give you the highest value in a given field, and average will give you the average value in a given field. We can see here, we are asked what is the minimum, maximum, and average bandwidth used for each website usage type. The average function ignores any event or row that does not have a value for the specified field or has a non-numerical value for that field. The values function allows us to list the unique values found in a given field. In this example, we are showing all unique values found in the user field and labeling this as usernames. We then count all the instances that a value is found in the user field, unique or otherwise, and labeling this as attempts. We then split our result set by the values found in the SRC IP field. The resulting table shows us for each IP address what usernames can be found and how many times any username was present for that IP address. The list function lists all values found in a given field, including duplicates. In this example, we've been asked which websites has each employee accessed during the last 60 minutes. The list function can be quite useful for creating easy-to-read data tables. Note that if an event contains multiple values for a given field, that's fine. Values found address. The list function lists all values found in a given field, including duplicates. In this example, we've been asked which websites has each employee accessed during the last 60 minutes. The list function can be quite useful for creating easy-to-read data tables. Note that if an event contains multiple values for a given field, that's fine. All values will be shown. Let's highlight the difference between the list and the values functions. On the left, we can see the list function being used. Every instance of a value within the S hostname field is being displayed, even if they are duplicates within a given username. On the right, we can see that the values function will only display unique values for a field within a given username. Given field to read last function was present the S as a considered. The non-use function allows us to list the unique. We can see how taking advantage of multiple functions within a single stats command allows us to pull some very powerful insights out of our data. Working with a simple result set from our base search, we are still able to set up a table that explores multiple aspects of our data. Here, we are only using values found in the price field, and splitting that by the values found in the vendor country field. Even so, those two fields alone can tell us the amount of products sold, the average price it was sold for, the range of prices found in our products, among other insights. The chart, time chart, and stats commands share similar features, but it's important to use the proper command to get the results that you're looking for. Let's take a look at this chart describing the differences in usable arguments across all three commands. First and most important is the number of arguments you can split your results by when using the by clause. With chart, you are limited to 2 fields you can base your split clause on. With time chart, you only get 1. That's because time is automatically selected for you as your primary split. Stats has no such limitation. Also of interest are some of the arguments available to you with chart and time chart that are not available with stats. Limit limits the number of visual series shown in a multi-series split. Filtering out null and other also refer to visual elements that you may wish to remove. An x-axis also only is present when referring to some sort of visual chart. The rule of thumb to remember is that the end product of the stats command is meant to be a table, while the end product of the chart and time chart command is likely a visualization. This will help you remember which arguments are appropriate in each case. The eval command can be used to perform calculations with values in your data. Before we explore its specific functions, let's take a look at how it's used. An eval expression perform calculations with the eval command can be used to perform calculations with values in your data. Before we explore its specific functions, let's take a look at how it's used. An eval expression is a combination of literals, fields, operators, and functions that represent the value of your destination field. The expression can involve a mathematical operation, a string concatenation, a comparison expression, a Boolean expression, or a call to one of the eval functions. In essence, the eval command is allowing you to create a new field on the fly, with the values in that field being populated by the results of your expression. This field can then be used the same as any regular field for the remainder of your search. It's important to realize that nothing written with the eval command is kept after the lifetime of the search it was used in. This means that the new field you create is not saved to your index in any way, nor will it be available again after the search is completed. In addition to creating a new field, the eval command can also be used to temporarily overwrite the values present in a previously existing field. In this case as well, no change to your data is permanent. The new values are not written to disk in any way. The eval command supports various operators in the expression of your statement. For arithmetic, we have addition, subtraction, multiplication, division, and modulo. For concatenation, we have a plus and a dot operator. The plus sign will concatenate any strings or characters. The dot sign will concatenate any data type. The expression also supports the AND, OR, NOT, and XOR Booleans. And we have our various comparison operators as well. Less than, greater than, less than or equal to, greater than or equal to, not equal to, and like. The eval command does require some fairly strict syntax that you should be aware of. For example, field values in the expression of an eval statement are treated in a case-sensitive manner. This is separate from how they are treated in a base search. String values should also be double quoted in every case, even if the string is only a single word. Field names, as opposed to field values, must be unquoted or single quoted if they contain a special character like a space. Also, remember to use a period instead of a plus sign when concatenating a string with a number in order to avoid data type conflicts. Let's give some examples of eval in action, as well as showing some of the different ways to write an eval statement. In this example, we've been tasked by the network team to show the number of bytes used by website type over the last 30 days. Now technically, this search satisfies that question. On the left, we can see the different types of websites visited, and on the right, we can see the number of bytes spent on each. However, this might not be a very useful result. It would be nice if we had a field such as kilobytes or megabytes. That's not available in our raw data, but we can create one with the eval command. I'll create a new field called bandwidth. the values in bandwidth will be as follows. The values in our bytes field divided by 1024 divided by 1024 again. This would give us the number of megabytes used in the same period. As stated before, we can use the eval statement multiple times on the same field. So let's do so to get rid of some of these decimal places in bandwidth. I'll call eval on bandwidth again, and this time I'll use a function called round. Round takes two arguments. The first is the number or the value you wish to round. The second is the number of decimal places you wish to round to. That's a much more readable chart. When we're done with this, I can actually remove the bytes column from my table as it's no longer useful to me. Another important point to recognize is that these two eval commands could have easily been accomplished with a single statement. Let's combine the two now. We can easily support functions within our expression. Another way we can accomplish this is by calling more than one eval statement within the same command. So let's split out these two again and see how this could be accomplished. I'll leave our initial value for bandwidth in place, but then I'll call bandwidth immediately again. Same result. Once we've created a new field with eval, that field can be referenced in the search pipeline later on. In this example, we've created a new field called bandwidth. We can immediately run other commands against that new field, things like sort or rename, or even perform a single or multi-series split with our new field. As we can see in this example, we can link more than one expression together to create multiple fields, and this can be done within a single eval command. Here we can see we've created a new field called current discount with the eval statement. Within the exact same eval command, we are then using current discount as a reference point for the expression in a new field called new discount. New discount is then used in the expression of a new field called new sales price. In the end, all of our fields are listed in the table. This can be useful when we need to show values step by step along the way as we convert. Eval functions allow you to convert, compare, and perform mathematical calculations on values in your data. There are too many expressions to go over them all in this module, but I have added a link to a comprehensive list in your notes. Let's take a high-level look at some of the most commonly used eval functions. Evaluation functions will evaluate an expression based on your events and then return to you a result. result. Now, this is not necessarily true for all functions in eval. Some do not evaluate any expressions, but instead return a result based on their own functionality. There are 11 different categories of evaluation functions. Some will convert values, some will compare values, some will perform mathematical operations, some will perform statistical operations, others will transform text, and many more. Here's a small sample of some of the functions available with the eval statement. For example, round will round x to y decimal places. Otherwise, if not given an argument of y, will return x as a whole number. Pow, for example, will return x raised to the power of y. We also have some statistical functions, such as minimum, maximum, and random. Here's an example of the pow function. In this particular case, we've created a new field called bandwidth. The expression that informs us of the values of bandwidth is the following. The values in the field of bytes divided by 1024 raised to the power of 2. In this example, we can see that power is given 2 arguments. The first, x, is the number we wish to raise, 1024. The second, y, is the number of powers we wish to raise it to. In this case, 1024 to the power of 2. The round function is also extremely commonly used. For round, we will take x and round it to the decimal places specified by y. In the example shown below, on the right-hand side we can see the field of bandwidth has many decimal places, probably more than we need. By calling eval bandwidth equals round, and passing round the arguments of bandwidth and 2, we can see that we have rounded bandwidth to 2 decimal places. It's a common practice to wrap the round function around the results of another statistical function. This way we make sure that our end result of the entire process is human readable. Max, min, and random, although perhaps less commonly used than pow and round, can still be incredibly useful. The max function will take an arbitrary number of arguments, either numerical or string, and return the maximum one found. Minimum is the opposite. Minimum will also take an array of numeric or string arguments, but it will return the minimum found. Random takes no arguments. Instead, when called by itself, it will return a pseudo-random integer ranging from 0 to 2 to the 31st minus 1. Here, we see a slight variation of the classic dice roll example of random. We're creating a new field called group, and the values in group will be as follows. The output of the random function to the modulo of 5. We then add 1 to make sure that our result cannot be 0. This will give us a random number between 1 and 5. We're then choosing to list the values in the user field as users by group. This would allow us to create 5 random groups of users. The eval expression can be used without functions. It doesn't necessarily require a function. Here we can see the creation of a field called discount. The expression that informs us of the values in the discount field are TLP minus TSP divided by TLP. No function necessary. Later on in the same search, we can see eval on discount again, and in this case, we're simply concatenating the current value in discount with a percentage sign. The eval command can also be used as a function with the stats command. In this example, we've been asked to count the number of events that occurred in a given time period where the vendor action was accepted, failed, or session opened. Here we're using eval as a function within the count function. The search is as follows. give me a statistical analysis and count events where now we eval, where the value of accepted is found in the field of vendor action. Relabel that a field called accepted. Further count where the value of failed is found in the field of vendor action. Call this a new field called failed. And finally, count all the events where a value of session opened is found in the field of vendor action, and call this a new field called session opened. This allows us to arbitrarily group values together that would otherwise be seen as multiple different splits. This does require an as cause to rename the newly created field. The eval command can also be used as a function There may be times when you want to display a more meaningful or user-friendly name for a field. To do this, we use the rename command. Renaming a field is fairly simple. We can use the command pipe rename, then the name of the field as it currently exists, followed by the as clause, followed by the new name we wish to give to the field. If your new field name contains special characters or spaces, be sure to use double quotes to encompass the entirety of your new field name. Here's an example where we rename multiple fields within the same rename command. Here, we have first chosen to rename the product ID field as product ID with capital P and capital D, followed by a comma. Then we rename the action field as customer action. And finally, we rename the status field as HTTP status. This slide also points out a nice example that your clauses, such as or by, do not need to be upper or lower case. These are in fact case insensitive. Note also that as customer action and HTTP status both contain spaces in their field names, we need to encompass the entirety of these field names with double quotes. Once a field is renamed, Splunk will only respond to or be able to use the new name of that field for the rest of your search. The example on the left shows what can go wrong. In this particular case, the user has renamed the action field as customer action and the status field as HTTP status. They then ask to give a table with the field's action and status. However, since these fields were renamed, Splunk no longer recognizes that there was ever a field called action or status. On the right-hand side, we see a better example. In this case, the user has further called a new command, sort as opposed to table, but this user has made sure to use the new names given to each field. As such, Splunk has no problem creating this table. We can also use wildcards to rename multiple fields that match a pattern. In this example, we've renamed the fields product ID and product name by changing product wildcard to prod wildcard. When we then base a table on prod wildcard, we can see that both of our original fields will appear. The sort command allows you to display a field's values in ascending or descending order. The syntax for the sort command is as follows: pipe sort followed by a minus or plus sign. This will determine whether you are sorting in ascending order by default with the plus sign or in descending order with the minus sign. The plus sign is implied, so you don't have to use it deliberately. Follow this with the field or fields you wish to execute the sort based on. If the field name on which you're sorting contains spaces or non-alphanumeric characters, be sure to enclose it in double quotes. Finally, if you only want a certain number of results, you can use the limit equals argument. or just put an integer representing the number of results that you want. Splunk will then determine the data type present in your field and sort appropriately. Alphabetic strings will be sorted lexicographically, numbers will be sorted numerically, and so on. Note that the sorting of alphabetic strings is done lexicographically as opposed to alphabetically. This means that uppercase letters appear before lowercase. We can see this in the example shown here, where BEE with a capital B gets placed before ANT with a lowercase a. In this example, we are asked to display vendor information for vendors that begin with BEA. We have our table already set up. We now just need to sort. Let's sort our rows based on descending order in the vendor field. Note that we have a space between the minus sign and the field that we're sorting by. This space can become important if you want to sort on more than one field. Let's take a look at the difference in two examples. First, let's add a comma and then another field to sort by. How about vendor city? Since we have a space between the minus sign and the first field in our list, the descending order instruction is applied to all fields in the list. We can see this in the vendor city values listed for the Beach Games vendor. Miami comes before Fort Lauderdale because descending order is applied in both cases. Contrast this with how results are sorted if we have the minus sign immediately next to our first field. In this case, we are telling Splunk to sort the vendor field in descending order, but then to sort vendor city in ascending order. Here, Beach Games still comes last in the vendor column, but now Fort Lauderdale comes before Miami in the vendor city column. Thank you for joining us to learn more about commands and functions that you can use when working with statistical data. We suggest you check out our documentation and register for additional learning modules with Splunk Education. Thanks for watching.